Hello everyone, good evening. Am I audible? If I am audible, you can just raise your hand. Okay, great. We will start the session by 4 p.m. Okay, just wait for 5 minutes. Hello everyone. Good evening. Yeah, I am audible, right? You can just raise your hand. Okay. I think we will be audible and visible to you. Just raise your hand. Whatever the doubts you are having, we just discuss your doubts in last half an hour. Okay. So we just remove the chart access and also video, sorry, mic access. You just note down all your doubts. Okay. And we can give the time for you to discuss. Okay. So I think most of you all are freshers, right? Mostly you are studying BTech second and third year. Mostly I think so. You are from autonomous college or universities. Okay. Is there any students from IITs and NITs?
Hello guys. Hello guys. Whether my voice is audible for all? Hello. Whether my voice
Yes,
is
you are
audible?
audible. Just they are just raising their hand.
Yeah, sure,
Your
sure, sure.
voice is audible.
Okay.
Murli, you
Oh,
can discuss more briefly from starting onwards. Last
yeah, sure.
20 to 30 minutes, we can give mic to the students. They will ask the doubts, okay?
Okay, sure, sure. Guys, please confirm like screen is sharing or not. Like, for you, just raise your hands.
Yes, it's sharing.
Fine. Thank you. Okay, again we'll start this workshop from the beginning. So, the main agenda of our workshop is like there is like a schedule for 2 days, which we are going to be discussed from RTL to GDSII. That means silicon to the chip. So it is the complete flow, like what are the things it will going to be happen in between the stages and cycles, everything else, and what is the role of a fresher if we want to enter into the VLSI industry, like what are the skills he want to learn. Okay, along with that, what are the areas he can able to he will going to be get a jobs and like what is this VLSI industry and what are the companies, what are the fabrication, how the fabrication will happen, what is this, all the things we are going to be discussing this. Okay, already the introduction is done. So once again, I'm telling like the agenda of this particular 2 days workshop is like first day we are going to be discuss about the semiconductor, the introduction to semiconductor physics as well as the VLSI industry. As a next is nothing but like digital design fundamentals for physical design. Like actually here we are not focusing deeply on the digital electronics. Here we are focusing like in such a way that in what level a PD engineer is supposed to understand the digital design. Okay, next is we are going to be discuss about the CMOS fundamentals. This is the basic thing. As a PD engineer, you want to understand how the transistor will going to be work, how this MOSFET will going to be work, and everything else. Next is nothing but ASIC flow, application specific integrated circuit design flow, like from starting stage to the fabrication stage. How it will going to be happen? What are the stages it will going to be include? And in between, like what will happen on the each and every stage, we are going to be cover this all the things. Next is nothing but a Verilog for physical design point of view, where this is the one of the major input which we are going to be taken for the Verilog, okay, for the PD. So like what is this Verilog? What are the things it consists of exactly? With respect to the PD, what we want to learn. Main objective is like as a PD engineer, how we want to see this all the concepts. So how it will going to be impact on your backend flow. That is the main agenda of this particular workshop of the today's. Okay. Next, if the time permits, we will see the synthesis fundamentals, and finally we will see the fusion compiler tool overview for today. And tomorrow we are going to be cover the tool completely. As we are taking the input as a RTL, how we can able to do this routing and everything, like in between what are the things will going to be happen and everything we are going to be covered by tomorrow's session. Okay, tomorrow's workshop. So, as we already discussed, like the semiconductor. So, what is a semiconductor? So, semiconductor is nothing but a which allows the flow of electrons in a partially. It is not like it is not allowing the completely. Why it is called as a semiconductor? So, that is the first thing we want to know. Like, so why we are calling it as a semiconductor means it is a material, it is a material whose electrical conductivity lies between a conductor as well as an insulator. That means it is not a pure conductor as well as it is not a pure insulator. It is nothing but in between the thing where it can allow the partial flow of electrons. Okay, clear? Guys, it is clear. Okay, give me a second. Okay, so as a semiconductor, as we discussed, like this is the thing which will going to be lies in between the conductor and insulator. So first of all, we want to know like what is meant by conductor. Okay, which allows the flow of electron full-fledgedly. That means whatever the input, what is the level concentration of the input we are giving, the same number of electrons we are going to be get at the output end. Okay, which allows the flow of electrons through that particular metal layer. For example, this is a connector means it will going to be allow that this all the electrons through this particular metal layer. Next thing is nothing but insulator. So insulator is nothing but which won't allow the electrons through that particular metal layer. So actually the insulator also consists of the particles such as holes and electrons will going to be present. But whatever the output voltage like outside, whatever the electron strength whatever we are providing from the external world, it is not enough to enter into this particular material. Okay, in between there is a thing it is called as a semiconductor, which will going to be lies between the thing. So example for the conductor, we are going to be tell it as aluminum. This all the things we are iron. This all the things we can able to tell for example for conductor. Insulator we can tell like wood or rubber. So these are the things will comes under the example for the insulator. Okay. So next is nothing but like so here mainly for the insulator semiconductor purpose we are taking the uh, silicon has a best metal layer, best metal. So why we want to take silicon as a best means because the cutoff voltage for the silicon is like 0.3 and germanium is like 0.4, sorry 0.7. If we are providing the 1 volt, so here the output we'll get from the silicon is like around 0.7. So as per the noise margin concept, so this is nothing but a logic 1 and this is nothing but a logic 0. Okay, so here in between 1 to 0.7 is considered as a still logic 1. In between 0 to 0.3 is considered as a logic 0 only. So with respect to this, here always there is a chance for getting a strong output. Like output has a strong. So that also one more reason. And next is like silicon is bit cheaper as well as it is more available than the germanium. Okay, so these are the things. And next, coming to this particular manufacturing, so the group of transistors are integrated together. uh, so that is called as IC, integrated circuit. That means a group of transistors are integrated together. So with respect to the particular application, with respect to the particular application, as well as we are going to be give a right, we are going to be implementing for the particular functionality purpose based on the application needs. Okay. Next, coming to the real-time examples for this, where the semiconductor will going to be stands and what is this all the means in our day-to-day life, what are the electronic graduates we are using. So one is like we are going to be called as a smartphone, you can going to tell, with respect to camera module or Bluetooth or fingerprint, like this, all the things will going to be work with the different modules with respect to the applications. Next, laptops, smartphones, and smart TVs. So these are the real-time applications for this particular semiconductor thing. Okay. Next is nothing but as a fresher, once we are taking that any course or once we are entering into the any industry, what we are going to be look first. So as a fresher, we will have the expectation of where I will get a job after completion of this particular course. If I learn the particular skill, so where I will going to be get a job. So what are the field and how this field will going to be, how this field was divided actually, like it was divided actually. So like this, first here we want to know these things. So while coming to the first, the product based companies like, yeah, Nvidia, Qualcomm, AMD, these are the and Intel, these are the companies which will going to be comes under this correlated companies, as well as there is a service based companies as well as the startups also. While coming to the service based companies, you may can tell as a TCS or HCL, these all the things. While coming to startups, we saw the many things. Okay. And next thing is nothing but a foundry. So here we are implementing something by using like some designs and all here implementing in this particular companies. So where these designs are manufacturing. So by using these two foundries, like this, many will be there. So here, as we are taking the example, TSMC and Samsung Electronics, these are the two places where they will going to be manufacture their design. Okay. So next, so to implement whatever the designs they are going to be implement in these companies, so what is the tool they are going to be use, how they are going to be implementing means with the help of this particular EDA vendors. One is like Synopsys, next one is nothing but a Cadence, and third one is nothing but a Siemens. So here we can't tell like each and every EDA vendor is like expertise for all the tools. So there is a specific, they are specialized for particular tools. So based on that thing only, the market will in the market they are going to be surviving. Okay. Next, why this particular, why the fisher want to choose this particular VLSI? Mainly, mainly because of the high demand in the worldwide. Like nowadays, the many fabrication units was establishing in the Gujarat and all like that. So and one more thing is like continuous innovation. Always the something new technology is like introducing. Always like as see in the olden days we can able to see a computer at the size of like our one room, but nowadays it is easy to carry. Okay, like this. The innovation is coming day to day. Next is nothing but attractive salaries also will be there, as well as the excellent career growth also will be there. So this also see here with respect to these four things also matter for a fresher who will going to be enter into the any domain, like either it is a VLSI or software, whatever may be the domain. So as a fresher, you want to know like where you are going to be see once you learn that particular skill, where how is my career and everything we are going to be look. Next, so this is the chip design life cycle, like how the chip will going to be manufacturing, like from where it will going to be start and from where it will going to be end. In between, what are the things will going to be happen and everything. So here, the chip will goes under the multiple stages. Okay, so what are the stages is nothing, but mainly the stages is specification, RTL design, verification, synthesis, sign off on paper. So this is the important stages. In between the other stages also is there. Further, like physical design consists of like floor planning, power planning, placement, CTS routing, like this. Like internally, many stages will be there. As an overview, at the basic level, we want to, you guys want to understand. That's the reason we are planning. I plan to explain this one. Okay. So here the specification. So the specification is the thing which is coming from the customer end. So for example, so I'm going to be use this device in the temperature of the 25 degrees Celsius, always at the high temperature. So based on that, we want to implement the particular chip, and we want to verify as well as we want to test the chip with respect to that particular specification. If we are implementing the chip, which will going to be work with the minus 40 degrees for properly, but it is not working with the plus 125 degrees Celsius. So, but my specification itself 125 degrees Celsius. If it is not working fine at that particular temperature, means there is a no use of designing that kind of particular chips. So this is the way the specification team will going to be get that where exactly and what exactly I want to implement, what exactly I want to design this particular processor. What is the purpose? Next, what are the specification it is given, taken from, we will get from this particular specification team. From that, in between, there is architecture team where they are going to be draw that blocks. So to meet this all the specification of the client, so what are the blocks we want to use it? Like there will be like some digital blocks in the inside the digital also logic gates is there, sequential combination like that. So what kind of components we want to use, for what kind of components we want to write the logic. So that thing will going to be told by architecture team. Okay. Then based on the architecture team, the RTL design team will going to be implement the logic as per the functionality they are going to be work. Then that functionality will going to be verified by the verification team. Okay. So then the backend team will come to the picture. Whatever the verified RTL is there, taking as an input for the synthesis. Along with that, some other inputs we are going to be take. Few from the libraries, another from the technology node. So based on the technology team, we are going to be take this all the things, and we are going to perform this rest of the all the stages. Here in the verification, we will check the correctness of the RTL. Synthesis will going to be convert this RTL into gate level netlist. Then physical design will convert the netlist into the chip layout. Okay. This is the thing. Next, while coming to the sign off. So sign off is a thing. Sign off is a stage where we are going to be verifying our design with respect to the correctness. Like whatever the things we did up to this here, like mean up to PD, whatever the things we implemented, we are going to be verifying it whether all the things are following the particular rules and regulations or what, whether everything is like proper or what. Is there any is there any mismatches? What is the expectation? Then what was implemented? So this all the things we are going to be verified at the time of the sign off, and we are going to be do the reporting. Okay. Next. So this is the thing will comes under the front end. As we saw that front end. So as a fresher, so there is a two way of students after once we completed with our BTech. So there will be BTech or MTech. There will be two categories. Few people were expertise in the coding, and few people were not expertise in the coding. So those who are interested in the coding, who are interested to enter into the VLSI industry, they will comes under this particular front end team. They can choose this front end team directly. Why? Because of in this front end team, we are going to be completely focusing on the functionality, and here we are writing the logical code. We are going to do the coding here. So by using the various skills like as a Verilog, system Verilog, UVM, with the help of this digital design. Okay. So if we are if that set of people are expertise with this particular skills, then they can enter. Then they can become an RTL design engineer or verification engineer or DFT engineer or synthesis engineer. Or you may going to be call it as a ST along with the synthesis, the ST engineer also we can able to become. Okay, in between some mixed signal engineers also will be there. Okay, so where they are aware of the both PD as well as a like front end as well as a back end. So like this different roles you can able to choose it. So if you are expertise in the code, if you are good in the coding, you are better you will suit for this particular front end part. Next. So few students who are afraid of this particular coding, like we don't know coding, I can't do coding. So at that time, where to enter for that kind of people, there also will be a chance for that kind of people as the back end, where it also consists of the coding, not much complicated. It is a basic coding level where everyone can understand easily and everyone can do that. While coming to this backend, completely here we are going to be focusing on converting that whatever the gate level netlist what we got into a chip layout. Okay, whatever the gate level netlist we are getting from the synthesis, we are the process will going to be converted into chip layout. Next, during this, what are the different engineers we can able to do? Like floor planning, we can able to do power planning, power engineer or placement, CTS, routing, and timing engineer here. and sign off engineer has a physical verification. So in between, one more thing also is there where the front end people can become as a formality tool, LEC, logical equivalency check, they can also do. So this also will going to be done by the front end people, or GLN simulation we are going to be called. So like different roles is there. So based upon our expertise area, we can able to enter into the different fields also inside this VLSI. Okay, next. If we are planning, if those who are planning to become a physical design engineer, they want to be expertise in the areas of physical design flow completely. That means this all the stages. This all the stages they want to supposed to be expertise. Then they want to be expertise in the analyzing the timing and you how to use the EDA tools as well as the tickle scripting. That means to guide this particular EDA tools, we want to use this tickle scripting and we are going to be guiding the particular EDA tools. Okay, what are those EDA tools means? Like the Synopsys, Cadence are those three are vendors. So there will be different tools is there. For example, if I am planning to do the synthesis, so one thing we can use as a genus from the cadence we can able to use, or from the synopsis we can able to use, or from the cadence we can able to use
Murali, your voice is not audible. Hello.
hello guys, sorry for interrupt. So Wi-Fi was disconnected. Okay, you guys can able to see my screen. Yeah, just raise your hands. Are you able to hear me? Okay, fine. Thank you. Okay, as we are discussing this particular backend. So in this backend, what will going to happen? Like these are the areas where we supposed to be expertised. Okay. So in this also like different job roles will be there as a STA engineer, as a PD engineer. Like see the roles are like STA engineer, like power engineer will going to be is there, and PD engineer is there from floor plan to routing who will going to be handle, and PV engineer is there. Okay, like this the different job roles also will be there in the backend also. Okay. So next, once this front end and back end, if you have a clarity, so then once we are expertised in this particular front end or back end, so what are the job roles we are going to be get? So that is nothing but already I discussed this thing now. So from the front end, the job roles are nothing but like RTL design engineer or verification engineer or DFT engineer. So is a different part where once the chip was manufactured, then with the help of these DFT engineers, we are going to be verify our chip. Like DFT stands for design for testability. So that is nothing but so design for testability. So we are going to be testing the design whether after the manufacturing also everything is proper or not. We are going to be verify here. Okay. So the same thing if you come for the back end, once if you are expertise in the back end flow, then there will be chances for getting a physical design engineer, STA engineer, PV like physical verification engineer, as well as a sign off engineer. Okay. If those who are both expertise in these two areas, then they can become a CAD engineer, application engineer, as well as the EDA tool developers. Those what are the EDA tools is using by the front end as well as the back end engineers. So that tool itself we can able to develop. Once if we are expertise with respect to this, all the EDA tools, what they are using. Next, once if we enter into the industry, then how the growth will going to be, like what is the positions we are going to be get. So as a first is nothing but a junior engineer or graduate engineer we are going to be called. Next is nothing but like senior called like staff engineer we are going to be called. They are nothing but a design engineers, then senior, then lead manager and director. So these are the two places where here we are going to be handle the team, and here they are going to be handle the group of teams, and here it will going to be handle the complete chip. The chip will going to be work under this working of the chip will complete under this particular director with respect to either you are a front end or back end, and all the teams will going to be monitoring by the director. Okay, this is a way you can see once if you enter into the industry as per your experience, it will going to be get. Okay, next. So as the main object of this workshop is for physical design, the main what is the responsibility of the physical design engineer. So while coming to here, the physical design engineer is the main responsible for converting this logical design. Okay, converting this particular logical design into chip layout. Okay, like for example, just here I am writing this logic as an okay, for example, the OR gate I am going to be take like O1 is a primitive. Y comma A comma B, this is my just in design. Like whatever the RTL logic I'm getting. So from this, I want to implement in this, I want to place, I want to do all the things with respect to this chip. So from here to, I want to convert into it into GLN, gate level netlist. Then the gate level netlist will going to be look like R gate with some instances name, some other like A1, A2 like this. From this, with the help of the technology files and every few inputs which is used for the physical design, we are going to be convert that into in the form of like this. So there is nothing but a two inputs, one output. So this is nothing but one kind of OR gate which is present in this particular file. So from this thing we want to took and we want to place here by following all the rules and regulations. Okay, like all the requirements we want to make sure. Like this, some millions of standard cells and some billions of standard cells we are going to be placed within this area. So not only we are placing these standard cells, we are going to be doing some power implementation. That means, so this is your chip like power, how it will going to be work. So if this is so these your macros you are going to be called like some modules which was predefined. So here you are going to place the stand cell means before this only the power supposed to be come from here. So this is nothing but a one thing will going to be connected for the VDD. That is nothing but like either okay according to us like 5 volts if you think. Next VSS will going to be has a zero point 0.0 volts. So this thing will going to be get a power from this out external world, where the power will get into this particular wire, from this wire to this particular mesh, where the standard cell is connected to this particular wire, and the standard cell will going to be work. So like this, you are going to be implementing this particular entire chip with respect to these two stages only. If you are going to be think, okay, with respect to this, we are going to do these two things. Means like this for each and every stage we have that specific specific activities what we are going to be take care. Like specific operations will going to be happen on the each and every stage. Next, so I'll coming to the placement. So in the floor plan and everything, the standard cells will going to be at this particular origin point of the core die area, like this. So this all the cells will going to be placed inside this core area during the placement stage. While coming to the CTA stage, so like how I am explaining about the gate, like this, some flip-flops will going to be present in your design. So this all the flip-flops will going to be get a power from this clock from this particular clock port to like this. So during the CTA stage, the clock distribution will going to be happen to the all the sequential components of the design. Either it may be a flip-flop, register, latch, whatever may be. So for all the sequential components, the clock will going to be distributed. Whether you are implementing the counter logic or FSM logic or any shifting like a data shifting logic or whatever may be. If there is a sequential component, the power distribution, the clock distribution will going to be happen by considering the two terms called as a skew and latency. So what is these two terms and why we want to consider, we will see further upcoming slides and all. Okay. So these are thing while coming to the CTS. And next, routing. In this routing, what will happen? Like in the placement stage, so one standard cell was placed here, another standard cell was placed here. In the routing stage, so still the standard cell just placed. There is a no connection between them. So in the routing stage, it will try to find a shortest path between these two things, and it will try to connect the both. That is the thing will going to be happen in the routing. So in between, it will follow the certain algorithms, certain protocols it will going to be follow. So based on that, all the things it will going to be connect this thing. Next, so here we have the clock, right? The same thing in the STA. What will going to be happen? Like always, if this is the clock cycle, if the data is launching at this first clock edge for this particular flip flop, means within this next clock edge, the data supposed to be present here. So if not, it will going to be called as a violation. So like this, there it was segregated into setup violation, hold violation. Okay, like different violations also is there. So like with respect to asynchronous, we are going to be call it as a recovery, removal, like different things. So we are going to be discuss that all the things also. Next, while coming to the sign off. So as per the foundry, they are going to be give some certain rule file, which we supposed to follow. Why? Because of like during the manufacturing, it won't affect, it's not supposed to affect the design with respect to shorts and open. So in the real world, if you think, so if you need two current carrying wires are near to each other, very close to each other, there might be a chance for getting an magnetic flux will going to be create and it will going to be short. So if the both wires are shorted, means it will going to be okay, has a functionality will going to be failure or wrong logic will going to be passing through. So that is the where if this is one standard cell, minimum some DRC distance will going to be defined. After that only another standard cell supposed to be placed. Okay, so that is nothing but like 2 lambda distance and 3 lambda distance. Here you may can ask like what is this lambda and how it will going to be. Okay, how it will going to be, we are going to be see this lambda and everything. Okay, lambda is nothing but like technology node what we are going to be called. In upcoming thing, I will going to be explain about this lambda, how this lambda value will going to be defined and everything I will explain. Okay, so this is the main goals of the physical design engineer. These are the main goals of the physical design engineer, where he want to focus on like completely timing, power and area. Okay, as well as the reliability. So the reliability is nothing but like how much duration my device can able to work, like up to what temperature my device can able to sustain, up to what level it can able to perform properly. So like that, the reliability will come to the picture. So once you got some idea on this thing, so then we are going to be looked at like as a fresher for the physical design engineer, where you supposed to be expertise it exactly. So with respect to the digital electronics, you're supposed to be expertise. Next is nothing but a CMOS basics. Like what is transistor, what is MOSFET, like why CMOS is coming into picture and how the CMOS is fabricating. Okay, this thing. Next is nothing but a Verilog fundamentals. Here, the depth knowledge of the Verilog is not required, but the fundamentals is required. Why? Because of if whenever you are doing that synthesis or anything, if you are facing any basic error in the industry, you can't tell to this particular front end team like I am facing this error for the basic things and all. So you can't tell like some error is coming, I don't know that error, so go and check. So as a feed engineer also, you supposed to identify that error and you supposed to send a report to the particular front end team. So when I am doing this particular process, so then because of this RTL logic, I am getting this error. So this is the error. So can you check it? Like this, we want to report to the particular front end team also with a proper, with a professional way. Like so, that is the way to identify that error. What is this error exactly? Whether it is just an basic input output port mismatching or any logical mismatching, you want to know that. So to know that minimum difference, what are the errors you are going to be get. So for that, we also, as a PD engineer, also need to learn this Verilog fundamentals. Next is nothing but ASIC flow. From starting to the ending, we are going to be go aware of this all the things. So that means where the chip will going to be start and how we are going to be get the inputs. So before stages, people like what they are going to be follow, who will going to be give the specification for them, who will going to give the inputs for them. So this all the things you're supposed to know. Okay, next is nothing but as usual the PD flow, HTA basics and Linux and figure scripting. So why this Linux? Because of as a PD engineer, we are using the EDA tools. It is nothing but automated tools. So where we can able to run some stages like easily. But once you run the particular stage, you want to you are going to be extract some outputs. Okay. So if you are doing some task, there will be some you are going to be extract some result, right? So that result is correct or not. We supposed to verify it. If anything is went wrong, what is the reason for that particular violation? What is the reason for that going as a wrong? So that thing you want to identify. So where the Linux commands will going to be help to the PD engineer to get that particular information. The very important Linux commands is nothing but like grep we are going to be called and SCD and AWK. These are the three things which will going to be help for the PD engineer to analyze that reports. If as a PD engineer you are very good and very strong with respect to these three commands, it is enough to analyze this particular reports. That is the case. Next is nothing but a tickle scripting to automate the particular EDA tool. Okay, next. So, is there any doubts until now? Like now, I'm going to be start the digital design. So, if you have any specific doubt, you can able to mention it. Okay. At the ending, we are going to see the particular tools and everything. Okay, fine. Yes, we'll provide the notes once if you join to the course. There will be like material access, LM portal access, and everything will also be available. Okay, fine. So now we are entering into this digital design with respect to the PD point of view. Okay, physical design we are going to be called in a short term called as a PD, physical design. Okay, so here why the PD engineer want to know the fundamentals of this digital design? That is a major object of this particular thing. Because of learning this physical design is important to understand basic of digital design. Why? Because of whatever the RTL is, whatever the RTL we are getting. So this RTL was written based on this digital design only. Based on this digital design only. So based on the digital circuits only, the RTL was implemented. So as well as like uh, when we are converting this RTL to GLN or from GLN to standard cell. Okay, standard cell where we are going to be see again these particular digital blocks. digital components, such as maybe it might be any gates, or it might be combinational, or it might be sequential, anything else. Again, here we are going to be see this particular digital blocks with respect to this thing. So this is the thing will comes under the completely PD point of view. So where you want to have the basic knowledge of this thing. So to identify like what is the block that was. Next, while coming to here, first we want to know the number system. So why you want to know this number system? What is the purpose means like, like there is a two ways, human understandable language and machine understandable language, where the computer can understand only the zeros and ones with some in the form of the encrypted format you are going to be called. But human can understand the zeros and ones? No. So that is the where the number systems was introduced. So here mainly the number systems was classified into four types. Those are nothing but a binary number, decimal number, octal number, and hexadecimal number. While coming to the binary number, it consists of only two terms, either 0 nor 1. So the base number is nothing but do. If we are representing any zeros and ones like this, and if we are representing in base 2, so this is called as a binary number, what we are going to be called exactly. Next, decimal. In the name of that, it only it will going to be tell like it consists of the 10 digits, like 0 to 9. So, so overall, if you count, it will going to be has a 10. So the base number was 10. So in between like 6 to 5, 10. So it also one of the decimal number only like this. Next, octal number. So 0 to 7 we are going to be called. Okay. So here the same number, if I mention like 6 to 5 with the base number of 8, so it will going to be called as octal. So its value is differ from this value. So that is the difference here. Next is nothing but a hexadecimal number. So up to 10, up to 9, you can able to use a decimal. Then more than that, how we can able to implement. So up to F, we can able to implement. That means up to 15, we can able to implement. That is nothing but hexadecimal number. 0 to 9, then 10 is nothing but A, 11 is nothing but B, up to F, that is nothing but a 15. So the base number is nothing but like 16, like 0 to 15 numbers, we can able to implement it. Okay. So this is the various types of the number systems and why we are going to be use that number systems. Okay. Here with respect to PD point of view, what is the usage? What is the importance of that thing? So these number systems and everything for giving the inputs and all, we are using in this RTL coding. And while debugging the netlist, like when whatever the netlist we are using, they the front end people are going to be do the GLN simulation whether the netlist is proper or not, or LEC we are going to be do logical equivalency check. That means whatever the logic is there in this RTL is same was replicated in the netlist like .v file or not, .gln or not. To verify that thing at the time, this particular number system will going to be helpful. Next, reading the reports also, this particular number system will going to be help with respect to timing report or whatever may be the report. Okay, next is nothing but a logic gates. So once the number system is done, then we want to have some knowledge as a PD. We want to have some knowledge on a logic gates. So first of all, in the VLSI, like in the RTL point of view, logic gates are predefined primitives. They are predefined. So that means if you write and, so by default it will going to be our tool will going to be assume like this is the functionality of the AND gate, like this some predefined things is there. So while coming to here, so the functionality of the AND gate, so there is a based on the truth table you want to decide we are going to be tell that what is the functionality of the AND gate. So when the set of inputs called as a 0 0, then what is my output? If like 0 1, what is my output? 1 0, what is my output? 1 1, what is my output? So you make it as a front end point of view, they will write the logic for 0 0. They are going to be expect the output as a 0. But in between, what will happen? How this 0 is coming as an output? That is the main task is there for the PD engineer. For example, with respect to the same simple design, I will explain for you. So there is an inverter. So if you are giving as input as a 1, output is coming as a 0. How my data is like inverting? So then the CMOS will come to the picture where PMOS is there and NMOS is there. Okay, it is nothing but a VSS, nothing but a logic 0. It will going to be called it as a VDD. Okay, next. So if this is the PMOS, it will going to be connected with the NMOS. So here I am giving the input. Okay. So for example, first here I am giving input as a 1. So here you want to know that when the PMOS will on, when the NMOS will on, and how it will going to be work on. So PMOS always on for 0, logic 0 has a input at this particular thing. So in the upcoming CMOS module, we are going to be learn like what are the terminals is there, and how the current will going to be flow, how the leakage will going to happen and everything. So here, whenever you are giving that input as a 1, the NMOS will going to be on. Okay. So whenever I am making it as giving input as a 0, at that time it will going to be work as a open switch. So you are aware of the switch logic, right? So it will going to be work as a like open switch. So like this. So where there is a no connection from VDD to this particular output. So at that time, whatever the thing is stored previous output in this particular load capacitance, it will going to be discharged to through the ground to by through the particular NMOS, where NMOS is in on condition. So then the output will going to be get as a 0 only. So like this. So this is the logic which was hidden in between this particular AND gate. Like this, you want to understand. So why the delay was happening? For example, here I'm giving the input at 0 nanoseconds. It will take certain like 2 nanoseconds or 3 nanoseconds. Why it is taking the 3 nanoseconds? Because of this kind of transistor logic is there inside this particular logic gate. Okay, so like this you want to understand with respect to PD point of view. So this is the various symbols for the various logic gates. In this there will be like universal gates also. Those are called as an AND and NOR gates, where most preferably as per the CMOS logic, we are preferring the NAND only. So why we are preferring the NAND, why we are not preferring the NOR? So that also I will explain in the upcoming CMOS module. Okay. So this is about this logic gates as a basic for PD point of view. So same thing once during our course time and all, we are going for each and every logic gate like bit more deeper. Okay. And we are going to be explain that all the things. So next is nothing but a combinational. So combinational is nothing but combinational circuit will going to produce the output based on the input. Okay. So here whatever the input combination you are giving based on this outputs will going to be decided. Okay. So it doesn't have any memory element like what is the previous output, what is the previous input, what I passed, that nothing it will going to be stored. Okay. Just if you give me the input, I will give you the output. That is nothing but a combinational. So while coming to the combinational, characteristics of the combinational components is nothing but no memory. That means it can't store the previous data. No clock. Clock is not required. If you give me input, I will give you the output. That's it. So output changes immediately when input changes. So that means now I am giving as input 1, I am getting output 0. Until unless I give the next input, it will going to be written like this only. Once if I give the input as a 0 here, then now my output will going to be vary either 0 or 1, whatever may be, like this. Next, what are the components will comes under this combination means? One is nothing but adder, subtractor, multiplexer, decoder, encoder, and comparators. So for example, if you're going to be speak about the multiplexer means like this, it will going to be look, okay. This is nothing but 2 cross 1 multiplexer. So here, this is nothing but I0 input, this is nothing but I1. So here will be selection line 0, 1. So if this selection line is 0, then whatever the input is there at the I1 pin, so same thing will going to become as output. So if my selection line is equal to 1, then this will going to come as output. So like this. So here, is there any involvement of the clock? Means nothing is there. So that is the way, no clock as well as no memory. Okay. Next example is nothing but like a plus b as a adder. So if input changes, output immediately will going to be changed. Here in this combinational, how what the PD engineer is supposed to be observed. See, if you are taking the combinational component as adder, then the area power delay will going to be vary. If it is a subtractor, it will going to be vary. If it is a multiplexer, it will going to be vary. For example, if you see in the multiplexer only, if it is a two input, it is a two input. For example, it will take 2 nanoseconds to generate the output. For example, if you it is a 4 input means it might going to be take some more, yeah, like some more extra area as well as some more time also. Okay, as well as to perform here the set of operations are 0 or 1, only two combinations. But here 0 0 0 1 1 0 1 1. To do this, all the four combination of switchings also, the power consumption will also more. As well as to verify the with respect to these three things, the delay also will going to be increased. As well as the area also, the component area also will going to be increased. So like this, we want to think in the point of physical design engineer. Okay, next is nothing but a sequential component. In this sequential component, so it is like only one component is extra than this particular combination component. That's it. So what is this extra component? So what are the characteristics of the combination of VISA? No memory and no clock. No memory, no clock. These are two things which we saw mainly. So while coming to the sequential, there is a memory element. Okay, it might going to be a register. Okay, next there will be a clock. Why? Because of the sequential component will going to be work whenever you are going to give the clock only. If you are giving the so sorry for interrupt. There is like some power cut issue here. Sorry for that. My screen is visible now. Just raise your hands. Fine. Okay. And here, while coming to this particular sequential, there is the two components which was introduced in this particular combination component. The one is nothing but a clock, and next thing is nothing but a memory element. Okay. And can you confirm like voice is clear?
Yes, it is clear.
Yeah, thank you. Yeah. In the sequential components will going to be depend on present input as well as the previous outputs. Okay. Next thing, it that means these circuits have the memory. That means to store these previous outputs, it consists of the memory component, like memory elements we are going to be called. So how we are going to be called in a simple way, if you want to if you want to explain. So here you have the NAND gate. Okay. So here if we have the two NAND gates here. So these are where the connection will going to be happen. Okay. Sorry, one second. So otherwise, we may going to be take with a simple example 0001 1011. So as per the NAND logic, the output will going to be 1 for all the stages. So if my first input is 1, can I define the output as either 0 or 1? No, but based on this previous output, we can able to determine this particular. So this thing it will going to be connect here like this. So that means if it is like 0 and here I am giving the first input as a 1. So based on the 0 1 combination, the output will going to be come here as a 1 from this particular AND gate. Sorry, NAND gate. Like this, the memory element will going to be the memory part will going to be play here. And while coming to here, what are the things, what are the characteristics of this particular sequential is nothing but like clock, which will going to be store the data as a memory element. Next, what are the example for this one is nothing but like flip-flops, registers. That means like group of flip-flops is called as a registers and counters, maybe up counter, down counter or whatever maybe, then FSM. We are going to be call it as, or else we can going to tell as a up level shifter. That means like right shift operator, right shift operation, left shift operation, like CISO, CIFO, this all the things, serial in, serial out, this all the examples also we can able to tell under this particular sequential components. Okay, next is nothing but a here coming to sequential components. What are the sequential components and why here we want to more focus on this thing? Because with respect to the PD point of view, okay, latch will going to be a level sensitive. That means so the output will going to be changed within this area. Like if it is a positive level sensitive, so within that thing, if my output is 1 at this particular point, if it is 0 means the output will going to be 0 at this particular point. But while coming to the flip flop, if my input is at this particular point is like 1, that means and this particular result is 1, if my output will change at this particular point also, that means the input will going to be changed at this particular point also, the output won't change until unless the next passage. So this is the difference between the latch and the flip flop here. Okay, so here we want to see like when based on the enable, the latch will going to be work and input directly reaches to the output. Okay. Next, what are the characteristics? Like, what are the characteristics of this particular latch? Is like it is a simple memory element, as well as it will going to be create the more timing issues. Why? Because of if this is the level triggering. If any small change will happen in this input, okay, instead of 0, here some triggering was happened. So at this particular end, with respect to this output, some glitch will going to be occur here. Okay, so because of this thing, it will going to be lead to a timing issue with respect to the PD point of view. So these kind of issues, this latch will going to be create. Next is nothing but a flip flop. As I already discussed, like it will going to be work with respect to the edge, either rise edge or fall edge, whatever maybe. So if it is a flip flop means like rise edge will going to be represent like this for clock. It is a fall edge where the flip flop will going to work out the fall edge means it will going to be represent with the bubble. It is nothing but a negative at the negative edge from 1 to 0. That is the difference. So while coming to the flip flop, there is a various flip flops called as a D flip flop, toggle flip flop, or JK flip flop. Okay, SR flip flop. That means based on the application as well as based on the requirement, we are going to be use this various kind of flip flops to implement that particular logics and all. Next. So most commonly using flip flop is nothing but a D flip flop. Why? Because input if I'm giving has a 100 megahertz, okay, the output will going to be get has a 50 megahertz. Okay, so with respect to this, my performance will going to be vary. So like this. So that is the reason most preferably we'll choose the D flip flop then over this particular JK, SR or toggle flip flop. Next is nothing but a registers. Register is nothing but a group of flip flops or a group of flip flops is called as a register where grouped together. I mean, a certain flip flops are grouped together, they are called as a register. For example, 8 flip flops are grouped together. That is nothing but 8-bit register, where we are going to be tell in the form of like 7 down to 0, where the single register can store up to 8 bits of data. That is the meaning of that. Here, with respect to 32 means 31 down to 0. Here we are going to be right like this. Okay. So if a flip-flop is like single bit storage element, if the flip-flop want to store more than one bit of data, then we are going to be group it, we are going to be call it as a register. Next, few more example for this particular sequential is nothing but like counter. Okay, for the up count as well as the down count. The real-time example for this up count and down count is nothing but like timer. You are going to be called in the day-to-day life as well as this frequency division and digital clocks. And while coming to this FSM, where this is the thing, mainly it will going to work as a controller or in this particular Verilog. So for example, like traffic signal, we are going to be called. So we are going to be tell like, okay, like 1.5 minute, like nearly like 120 seconds, the red signal supposed to be. So once the 120 seconds it will reach, then the yellow signal supposed to be. So once it will reach to the 60 nanoseconds, then it will go, the color supposed to be changed to the green. So like this. So here it is controlling at the particular clock edge. So if this is the clock edge, okay, if this is the clock edge, we are going to be called. So 0, 5, 10, 15. So these are time period. Like from here to here, that one cycle is nothing but 10 nanosecond, it will going to be take. So until 120 means up to 12 cycles, the output supposed to be replicate as a red color. Next, once it is like reaches to the 12th cycle, from the 13th positive or negative edge, the light will going to be changed, supposed to change to green like this. So it will going to be controlled with respect to that thing. It consists of a state, input, output, as well as a transition. State is nothing but like what state we are, whether it is in the red color, green color, or yellow color. Next, based on what input it want to go for what state, like this, and transition from one stage to another thing. Why it is important means like mostly it is nothing but a controlling logic in the particular chip, where it will going to be control the operation of the various components. Okay, when the clock supposed to go for the particular block, that mean if this is your chip, okay, so this is my FSM module. So these are the various modules where I am sending the data, for example. So from this module I am sending the data to this, to which module the data supposed to want to go at that particular time, on what time, for which module the data supposed to be sent. So these things are now will going to be controlled by the controller. Like enable signal, we are going to be called mainly in the digital point of view. That enable signal and control signals are nothing but this FSM will going to be control that things. Next. So here only we want to learn about this timing concepts. Okay. So as in the PD, we are going to be learn the deeper about that particular timing concept. But here, as a with respect to this RTL itself, we want to learn some basic level of timing thing, like what is mean by contamination delay, what is mean by propagation delay, like this. That mean here the contamination delay is nothing but if this is the clock edge. Okay, if you are going to think this is your clock edge, so the output changes. The initial change in the output you are going to be called. If this is the output signal, the initial change, like the amount of time it is taking to from zero state to one state. Okay, next. So after that, how much time it will going to be? In the real world, no signal will going to be like this. The signal always will going to be like this only. I mean, real signal is nothing but a sinusoidal signal we are going to be called. Okay, like the initial change is not the amount of time taken from the to the change in the initial output state. Okay, that is nothing but a contamination, and permanent change in the output. That is nothing but a propagation. So like this. So the timings, delay concepts also, timing concepts also we want to learn. Here there is a two things called as a launching and capturing mainly. So if this is a register and this is the one more register. Okay, this is the one clock. The same clock is going for this thing also. Is the data. Okay, CLK is the clock. This is nothing but a launching clock. Why we are calling it as a launching? So whatever the input it is getting, it will going to be launched here. After this particular combinational combinational logic, the output will going to be going here. That means this output is the input for this one. So the input of the second flip flop is depending on the first flip flop. So that is the way it is nothing but a launching, which is giving the data, giving that input to the second thing. Capturing is nothing but taking. So that is the way we are going to be call it as a capturing. Okay. These are based on this is the thing we are going to be analyzed in the STA. Mainly in the STA, we are going to be analyzing the point of reg to reg and into out and reg to out. So here the concept is like this is one register, this one register. Here I'm checking the timing, how much of time it is taking to get data to reach at this particular register. That is nothing but a reg to reg based timing analysis I am going to be do here. Clear? Just raise your hands, okay? It is yes. Next, what is mean by setup time? What is mean by hold time? This is the two main concepts is there. Setup time is nothing but the data is supposed to be stable before the rising of the clock. That means if this is the clock signal, okay. So if this is a circuit, this is the circuit, this is the clock signal. Okay, whatever the data is there, it's supposed to be stable here before this rise edge. The data supposed to be go at this particular point before the rise edge. That means at this part, this is nothing but a setup margin we are going to be called setup window. So that means if it is a 10 nanosecond is your second rise edge will going to be occur. At 8 nanosecond only the data supposed to be stable. If not, the data was coming, that means the data is arriving to this particular flip-flop after the 10 nanosecond, if you think, like at 11th nanosecond or 12th nanosecond, that will going to be called as a violation. Okay, so here setup time is like 50 picoseconds. The data must arrive at least 50 picoseconds or before the clock edge. If not, it will going to be called as a violation. Similarly, hold. That means this the whole violation we are going to be check at the first rise edge of the clock itself at the time at the case of this launching flip flop. So once the data was changed from 0 to 1 or 1 to 0, minimum time the data not supposed to change its state to some other thing. Okay. So if there is like sudden changing like this the data, that means here if there is like sudden changing in the data, so at this particular up to this point the input was 0, up to this point the input was 1. Finally the data will going to capture as a 1 only, but actually what is my first data? That is nothing but input as a 0. So now the wrong functionality will going to be happen, like now that it will going to be leads to functional failure. That thing, that's the reason here we want to make sure the data not supposed to be changed its state from this rise edge to this up to this particular window at least. So this is nothing but a hold violation or hold timing analysis. Okay. So if the hold is occurred, wrong data may be will going to be captured. If there is a setup violation, it will going to be affect the chip may fail at the higher frequencies. These are two difference. What we are supposed to learn in this particular timing concept. Next. Next is nothing but a Verilog for physical design engineers. Okay. So is there any specific doubt with respect to this digital design for anyone? Okay, then I will proceed with Verilog phase. Once again, explain setup and hold. Okay, fine. Okay. Setup is nothing but like the data supposed to be stable before the rise edge of the clock. That means, so this is your clock period. Okay. And so this is your input. This is your input. So the input supposed to be ready. The data supposed to be ready at least at this time or before the particular rise edge or at least at this rise edge. If not, my data is coming at this particular thing after the rise edge. Until unless the next rise edge, I can't fetch this whatever the data is coming here. So it will going to be leads to a setup timing violation. That means with respect to the circuit, you are going to be called like this. So there will be a combinational logic here. Okay. So the data supposed to become before this margin. That means as per the clock, you are going to be tell like the clock will going to be reached to the second flip flop at 10 nanosecond means data at least supposed to be come at 10 nanosecond, or else it's supposed to be at 9 or 8 nanosecond. If not, it will going to be called as a violation. If it will come at 11 nanosecond or 10.1, if you're going to be call it as a 10.1 nanosecond also, it will going to be called as a violation only. Okay, next, well, coming to the whole. So once once here at this particular first flip-flop, here whatever the input I'm giving, to certain time I'm not supposed to provide the next input. That means it might going to be 2 nanoseconds. If you're going to be think it as a 0.2 nanoseconds, so every input I want to give after 0.2 nanoseconds only. If I give the first input as a 0, I want to wait the 0.2 nanoseconds, and then I want to give the next input as a 1. Again, I want to wait the 0.2 nanosecond. Next input I want to give as either 0 or 1, whatever may be. So like this, we want to maintain. If not, for every 0.1 nanosecond you are giving the input, here the hold margin window is nothing but 0.2 nanoseconds. Up to here, initially the input is 0. Then within this time here I am getting as a 1. So then the data will going to be get output as a 1 only. Okay. So then the functional failure will going to be occur. Instead of AND gate, here I am giving to AND gate inputs are nothing but like, here I am initially I am giving 0. It is 1, constant 1 you are going to be think. So 0 is non-control, 0 is a controllable input for AND gate. So if I am giving the input, by default my output supposed to get 0. But within this, like to reach from input to this particular gate, it is taking 2 nanoseconds. Immediately here I am changing 0 to 1 means by default the output will going to become as a 1. But what is my expectation? It is like 0 as per my requirement, but it is coming as a 1. So it is nothing but a functional failure. It will going to be occur. I hope it was clear. Sorry, like at the finally we can able to discuss that thing. I wish like okay, because others are waiting, right? We'll continue that. So at finally I can give the overview of that thing if it requires for you. Okay. Now we're coming to the Verilog module. As a digital, we saw like what is the why we want to know this particular number system, gates, sequential, and combinational with respect to some examples. Next, while coming to the Verilog. So why the Verilog is important for the physical design engineer perspective? How it will going to be impact on the PD? So that is the thing. We'll come to the picture here means. So first thing, here we want to look. Before starting a PD, we are receiving the RTL code written in the Verilog format or .sv system Verilog format or VHDL format. Okay, hardware description language, HDL format, we are going to be called. So here in the Verilog, this is the Verilog which we are going to be taken for the synthesis as an input, and from the synthesis we are going to be convert this Verilog as a gate level netlist, and from there we are going to be taken as the input as a gate level netlist to the PD, and we are going to be implementing this chip layout. That is the main objective. Next, so if there is like the RTL is not proper, so whatever the logic they wrote, they are not following the certain guidance, like what is the way and what are the components they are using, and how many inputs they are declaring, how many outputs they are declaring, and what kind of code they are writing. That means if you are going to be write that if logic, if it will going to work like differently. If you are going to use the for loop, it will going to work differently. While loop, like this. Based on the different things also, this all the parameters will going to be okay. So how it will going to be impact and what perspective it will going to be impact, we are going to be see. Okay, now. So this is the first thing. So Verilog will going to be start with the term called as a module. It is a basic and very important thing that one should know. This is nothing but a module. Okay. So after that, whatever the thing is there, that is nothing but a module name. Whenever the PD engineer is doing the PD, whenever the PD engineer is reading that RTL, he want to know this particular name before only. Because during that analyzing that RTL is not required, path is enough. Whenever you are doing some other stage called as elaborate or set top module under, you want to know the top module name. So this is nothing but a name of this particular RTL code. Module name you are going to be called. And this is the way we are going to be declare the input for single bit. As a single bit, we are going to be declare like this. If it is a multi-bit, so then we are going to be declare like as a input 2 down to 0. That means it can able to store up to 3 bits as a A. If it is output means reg, output reg, here we are going to be write the output, reg of 10 down to 0. That means it can able to store the 9 bits of data like this. It is a more than 1 bit. It is for the single bit perspective. Here we are writing. Use a simple logic for the sum of two numbers. So this is nothing but an module. So this is the way the basic syntax of the RTL code we are going to be look. So here you want to understand the two things. One is like RTL engineer is supposed to know how it was declared. Next, if you don't know about this logic also, it will be fine. As a RTL engineer, as a from the RTL, as a PD engineer, you supposed to know this. What are the different ways we can able to declare the inputs, as well as what is the module name, which is called as a module name, from where we are going to be get this module name. That basic things we want to know. Okay, so if I want to use a single thing called as the input as well as output, then I can able to declare it as a in out. If it is not a port, for example, I not required any port. This is nothing but this is a port. But if not required any port, but I want to use it to connect between the two components, then we are going to be call it as a wire. Okay, so it won't store the data. Just we can able to use it either it as a input or output, whatever maybe you can able to use it as a wire to connect between these two things. For example, these two things is there to connect between these two components. Here I'm using as a wire has a A. That means this whatever the wire is there in between the both, that is called as a A. Okay, so like this kind of things we want to understand as a PD engineer. With respect to PD point of view, what are the things one should learn? So one is nothing but this thing called as a when we see a module. So we want to observe what are the input ports, what are the output ports. Logic becomes gate after the synthesis. Like here I am writing for adder logic. So if I get as a netlist has a subtractor logic, whether it is correct? No. So that comparison also is required. That is the way the LEC will come to the picture. Logical equivalency check between this particular RTL as well as between the after the synthesis, whatever the GL and gate level simulation is coming to us. Understood? Like this. Next, here mainly the few terms is there. Like now you are aware of that how to what are the things you want to focus on module name, input and output. Along with that, there is a most probably we are going to be face the warnings while we are reading this RTL during the synthesis. What are their warning? What are those warnings? Why it is coming? So why? Because of here see here I am writing these two things. For example, here I am not declared the Y, but here I am using Y. At the time, they are going to be get a warning called as a Y is not declared. That means it is neither not it is not a not a input, not a output. Like this, it will going to be declared. That means undeclared parameter is using in the code. While analyzing, it will going to be throw this kind of warnings. So this kind of warnings only future it will going to be lead to errors. Okay. So there will be like three ways for a PD engineer also. First thing called as the information. Okay, like just a aware alertness it will going to be give. Then it will going to give the warning. Like if you are not fixing this one, it will going to be impact on future. Then finally you are going to be get a error. So once if you get any error, you want to first observe you want to observe about the warning. What are the previous warnings is there? Before the warning, what are the informations it is giving? Based on this information as well as the warning, we want to fix this error. Error fixing is not like as a directly fixing that error, whatever the error is coming. First of all, we want to learn the thing, how to analyze that particular error, why that error is occurring. So this is the way we want to do. If we are aware of these things, so while we are reading our RTL, we can able to fix it. If we are not aware of like what is mean by wire, what is mean by reg, what is input port, what is output port, what is a module name under, we can't fix it. Directly we are going to be give to this particular front-end team, then time to market will going to be delay again. Okay. So this kind of things also will come to the picture. So here wire is nothing but like use it to connect the signals wire A, wire B, or wire Y. Like this, we are going to be declare represent a physical connection between the two components, this wire, but it can't store any value. This is the functionality of this particular wire. It is clear? Next, while coming to the rig, especially we are going to be using the procedural block. That is, procedural block is nothing but always at the rate block. Okay, this is not a procedural block. It's a non-procedural block. Okay, this is nothing but a procedural block. Always the initial we are going to be used to write that whatever the logic we are writing, we are going to be write inside that thing. So those are called as the procedural blocks. So for them, whatever the inputs and output declarations we are using inside that particular logic, there we are going to be represent with the reg format. Okay, use it in the procedural blocks. Next, it will going to be represent with the form of reg, some particular input name. The key components, like key points for this particular reg is like it can hold a value until unless the next value will come. Next, it is mainly used with sequential components for sequential components. Okay, so this is about the module structure. Next, here, and one more thing is nothing but a continuous assignments and procedural assignments. So, what is my continuous assignment? What is my procedural blocks and everything? So, while coming to the continuous assignment, it is mainly used for the combinational circuit. Procedure will comes under the sequential thing as well as the combinational thing. Both things we can able to use it. But continuous we are using only for combinational. Here, this is the logic which was written in by using the continuous assignment as a equals to. So, this is the outcome it will going to be get as a AND gate. Okay, with respect to the PD point of view, what we want to learn, how we want to observe them in, the synthesis tool will convert this statement into standard cell available in the technology file. That means, first of all, how the tool will going to be convert this thing is like, so whatever the assign statement is there here, whatever the assign statement was written here, it will going to be convert into first as a y equals to a ampersand b in the form of some Boolean expression. So in between, certain optimizations will going to be happen. There again, this Boolean expression is converted as well as assigned into one gate called as a AND gate. AND gate with the name of A1 with some name of Y1 is the output and A1 and A2 are the inputs. Like this, it will going to be represent here. So based on this thing, by using this reference from the standard cell, that means we are going to be get the standard cell information from the .lib file. From the .lib file, we are going to be get. So same instances, it will going to be search here as per the specifications as well as the requirements and whatever the inputs we are giving for the particular tool, then it will going to be mapped with the particular shell like this. It won't look like this. Actually, it will going to be look like this. Okay. So if you say what is there inside the logic is nothing but this is the thing. Understood? I hope it was clear for everyone. Next, procedural blocks. Where procedural blocks is nothing but like always block is used to describe the hardware. That, that means whatever the logic we are writing inside always at the rate. So that those are comes under the procedural blocks. For example, the combinational thing y equals to a and to b. So same logic here before we assign we wrote with some assign statement as a simply, but this is the difference between the both. Next, sequential also we can able to write it. So this is the syntax for sequential. Always at the rate, passage clock, begin with, that means these are where they are going to be right. So some module name, every declaration will be there. Always at the rate with the passage you are going to be called. Passage clock is the next is nothing but like begin we are going to be written here. Then here we are going to be start that particular brace and you are going to be you has ascending. Next it will be end. Next in model like this, it will going to be like here it is the begin, it is the end. In between the logic we are going to be writing in the sequential in the procedural block format. Next, while coming to the physical design perspective, how we want to observe this one means always block are synthesizable into a actual hardware components. For example, if I am using as a q less than d means and it will going to be assigned directly to this kind of flip flop. Okay, so that means this is the Q is my input, sorry, Q is my output, and D is my input, like this. That it can able to assign for a hardware components. That is the case. Direct assigning will going to be happen. Next, blocking and non-blocking. Because of this, mainly the delay, like timing analysis, will going to be impact if you are going to be speak. Why? Because of, see here, as in the blocking statement, they are writing as a always at the rate star. That means whatever the input changes, output supposed to be changed here with the begin A equals to B, then C equals to A. That means first A want to the B want to go and store in the A, then whatever the value in the A will going to be stored in the B. That means this is the first thing will going to become. So B will come to this particular A, and A will going to be input for the next one. Here also A will going to become, this is your output. Here see, it is taking this much of time. That means this is the one more component, area will going to be increase, and it will take some time to reach from here to here. The delay will going to be increase, and to on and off, the how the sequential component will work with the help of the clock. That is nothing but switching from 0 to 1 and 1 to 0. Because of this switching, the dynamic power consumption will going to be occur. So here with respect to this PPA will going to be impact based on this blocking statement. Most preferably we won't prefer the blocking statement for the low power design or high frequency designs especially. Okay, next is nothing but a non-blocking statements. So if the same statement is there, like A equals to B and C equals to D, so at the zero time simulation, the this value will going to be assigned to this one. It won't bother about this thing or this one. So it will going to be represent with the less than or equals to. So directly this value will going to be represent like will going to be assigned at the 0 nanosecond, at the same nanosecond. Okay, this is the case. And there is a one more two things you which as a PD engineer you want to learn. That is nothing but initial begin is one more thing is there, and next thing is nothing but always. So in your RTL code, if you have a 10 always blocks, every always block, every procedural block will going to be run at the same time, 0 nanoseconds. As well as whenever the input will changes, every time it will going to be changed. It will going to be work again. But initial begin is nothing but like one time logic, like where it will going to work at a time only. It won't work all the cases. Like if I change the input also, it won't work until unless I run the particular block. But here, if the input changes, the output will going to the entire logic will going to be re-execute again. So this is the thing with respect to the interview point of view, they are going to be asked this thing like how you are going to be represent and what kind of the thing you are going to be choose for which kind of components. Mainly for the combinational, we are going to be prefer the combinational like combinational components is like blocking statement, blocking assignment, and while coming to the sequential, we are going to prefer the non-blocking assignments. These are two things. This is also important with respect to the PD point of view. Next is nothing but a combinational sequential logic. So here I am giving just a basic code based on that how the based on the particular digital component how the logic code is going to be implemented. That is the basic thing I am giving here. As a there is the first thing is nothing but is combinational component. Here is nothing but combination component. Here see this is the my mux. So here the my mux name was like 2 cross 1. So what are the mux I taken here? So this is the same module name which I was given here. Next, here I have the two inputs, I0 and I1. That is nothing but A, that is nothing but a B. I was declared. So there is a one more selection line. That also one of the input. That is the way I declared as a SCL. Next, this is nothing but a Y. This is nothing but a output. Okay. Next, here you make an here you supposed to get one more doubt. So once if you get a specification from the customer, then the architecture engineer will going to be decide this kind of things. What's supposed to be input, what's supposed to be output, this all the terms like input, output, ports and all he will going to be decide. Based on that only we want to use and we want to write the logic. Next, here I'm using the procedural block. So inside the begin, if my selection line is indicates like if my selection line is nothing but a one, if you nothing mention here means that will going to be equals to 1. That is the meaning of that. So if whenever my selection line is 1, the path will going to be connect like this. then the Y is supposed to get the output as a B. Whatever the either it is a 0 or 1, whatever may be the input, it will come at the output. Else, if my if condition is failed, then it will go for the else condition. Then the rest of the logic, this thing is going to be activate here. So this is the way the combinational component will going to be work. See, in the same format you can write for the encoder, decoder, or any adder, subtractor, or ALU blocker, anything else which doesn't have the clock. With respect to the PD perspective, you want to increase. If see here I am taking only one selection line. Here the inputs are 0 or 1 only. If it is like two variable, like 4 cross 1, there will be like two selection lines 0 0 0 1 1 0 1 1. If it is like 10 cross 1 or 8 cross 1 mux means it will going to be get like 3. Like the combinations will going to be increased. To check with respect to that all the combinations, it will going to be take that more time. So it will going to be impact like that. Okay, clear? Next is nothing but like here with respect to that, how it will going to be impact means with respect to the area, delay as well as the conjunction, it will going to be occur. Now we are going to see this sequential component. So here has a basic gate, which basic flip flop. What we are preferring always is nothing but a D flip flop. For that is a flip flop. I am presenting this example for you people. Here also same thing. The module and module name is given. Here one input is nothing but a clock. Next input is nothing but a data. That is the way two inputs were declared. And here we required one output as a Q. So if it required this one also, we can able to declare here as a Q comma Q bar. Like that also you can able to declare it. So whenever my passage is coming, that means if this is the clock I am giving as an input to this particular register like flip flop, so whenever my rise edge will come, then whatever the data in the queue it's supposed to be get at the whatever the data, whatever the input in that particular D terminal, it's supposed to come to Q. That means it's supposed to go here. So you can ask me like whether within this all the areas, if any data changes at here, it will going to be impact. No. So until unless the next rise edge, it will going to be stay with the same input what it was captured at the previous rise edge at this particular rise edge, and then whatever the data is there, it will going to be keep it until unless the next rise edge. Like this, the sequential component, like the sequential model, will going to be work. Here, with respect to this PD point of view, you want to think about the area as usual. Main thing is nothing but a power because clock is a continuous switching signal from 0 to 1 and 1 to 0. When the switching is happening, the dynamic power consumption will going to be happen. This is the biggest power consumption which will going to be happen. Okay, what is dynamic power consumption? How it is occurring? We will see in the CMOS model, like clearly. And it will going to be leads to a complex in the CTS network also. If there is 1,000 or some 10,000 number of sequential components, it is difficulty to distribute the clock for all the sequential components at the same time. Where my clock network will going to be, if this is a clock port, if you think, it will going to be connect like this. So this is the where my clock distribution will going to be occur. Exactly. It might be in the two format like single point CTS or multi-point CTS. That is a different case. Where this is the where the logic will going to be occur here. So here there will be like group of registers like this. If you are going to be called, so the clock will come and connect to this one like this. So now this registers, all the registers will going to be get. Clock will going to be get at the same time. Like this, the sequential and combinational coding will going to be impact on the PD. Okay, that is the way the whatever the logic and whatever the logic they are choosing while writing the RTL also matters for the PD engineer to work with the power performance and area parameters. Okay. Next is nothing but like here with respect to the single like simple things like how what are the possible reading that RTL. That means whenever we are reading the RTL, what will going to be happen, what component will going to be introduced like this. So in your RTL, whenever you are writing the RTL logic, if you are using the procedural block as always at the rate passage or negate whatever may be, then flip flop will going to be the hardware component of the replacement of that particular block. Hardware component of this particular always at the passage is nothing but a flip flop. Either it may be Is going to be effect on the clock as well as the CTS effects also. But the hardware component for the always block is nothing but a flip flop. Next, if it is like arithmetic logic, so it may going to be a combinational component. Might be a combinational component is a hardware component for that thing. Might be the OR gate you are going to be called. Okay, like OR gate we are going to be called as a two inputs. So this might be
The PPT is visible for everyone. The presentation is visible for everyone. Can you raise your hands if it is visible? I am enabling the chat box. Please write your answer in the chat box. Is it visible or not?
yes.
Because some students, some people sent a mail to me. It's visible, right? Okay, okay. Okay, sure. In just few minutes, we will directly jump into the Synopsys tools. Okay. We will show you the introduction of Synopsys tool today. Tomorrow, entire PD flow we are going to discuss in tool. Okay. Yeah, fine, fine. Thank you. Murli, you can continue.
Yeah, thank you, ma'am. That's like what are the theoretical we are seeing here. The same thing at the end of the section I am going to be show you with a practical thing how this particular thing we can weave in the PD point of view and everything. Okay, don't miss that last half an hour session, especially like okay, where you are going to be get this theoretical knowledge, you can convert it to a practical thing directly. So if we are using any case statements in the RTL logic, then it will going to be replaced with the hardware component of has a mux, as well as is there any passage or negate clock. So it will going to be replaced with the particular CDC concept like clock domain crossing concept, because if there is a more than one clock for a single RTL, for single block, if there is a more than one clock for say, to perform a single operation, then the CDC will coming into picture and it is going to be implementing the things. Okay, next. Because of this RTL, what are the issues as a PD engineer we are going to be face and how the PD engineer will going to be affect? That is the objective. So if one is nothing but a high fan out signal, so that means so this is the one gate is there. For example, the output of this one gate is connected to the 100 things or 10 things, but it can it has the capable of driving. It can go as an input for only 5 flip-flops or 5 input pins. But instead of 5, if I'm giving the more than 5, the signal strength will going to be reduced. Then whatever the input you are giving at this end, it won't reach at this particular end. So because of this, signal integrity issue will going to be occur. So this is the one impact. And one more thing, here see, the n number of routing metal layers is required within the short area. That will going to be leads to the routing congestion. If the data is going slowly from here to here, it will going to be leads to a timing violation also. Like this different way, in the different perspective, the PD engineer will going to be effect for each and every simple mistake. What is happening, what is occurring because of the RTL code. Next, it is nothing but a deep combination logic. That means, see, as I told you before, this is the one register and this is the another register. What we have in between, some combination logic is there. Okay, what I told. So this is the first rise where the clock data will go supposed to be clock will going to be reached to the launching. At the next rise, the data supposed to be captured at this particular flip flop. Because of the CL, like logical depth, you are going to be called. The CL is nothing but a logical depth. Okay, so because of this logic depth, the data supposed to be come at the 10 nanoseconds. Because of this combinational delay, it may going to come at 12 nanoseconds. So this also can lead to a timing violation. This thing. So at that moment, what will happen? Like whatever the data supposed to be fetched at the second clock cycle, it is fetching at the third clock cycle. So the clock frequency also will go. The operating frequency also will going to be affecting. This is the case. Understood? So like this, you want to understand. For each and every term, you want to correlate with the PD thing. Next is nothing but a large muxes, which will going to be create the area, delay, and congestion issue. And next is nothing but excessive flip-flops. That means like back-to-back flip-flops, like continuously using the flip-flops. Like here is one flip-flop. So you can maintain this much of distance. Instead of that, you are using again one more flip-flop, again one more flip-flop. So it is not required. Okay. So what is happening here? So whatever the one is the input means it will go here. Again, the one will come to here. Again, it will go here. Instead of this flip-flop, directly I can able to use only two, right? So this kind of things, if you are introducing this kind of flip-flops also, it will going to be effect with the area, power as well as the CTS complexity. Mainly the clock supposed to be give for everything else. So this kind of all the issues will going to be occur. Okay, mainly with respect to CDC concept. So this is about the Verilog module as well as the digital module. So now exactly these are where we are going to be entering into the PD. Like this is the basic for the PD where you want to learn like how the standard cell was implemented, how this transistor was implemented, how it exactly is going to be fabricated and everything. Okay, I hope it was clear. Until now, it was clear. Verilog as well as the digital phase for the PD perspective. Good. So here we are explaining only the overview of the things. Okay. So once we start the batch for the once you taken in the once you join into the course and all, it will going to be much more deeper. Okay. Next, CMOS fundamentals for physical design engineer. So first of all, CMOS stands for complementary metal oxide semiconductor. What is meant by this complementary? So CMOS consists of both PMOS and NMOS. Okay, PMOS, NMOS is there. Actually, MOS is means PMOS and NMOS. So where this PMOS or NMOS will going to be work oppositely. If it is on for one, like it is on for zero, it will going to be on for one. That means at a time it won't work. If the both transistors are on at a time, whatever the VDD here you are giving, same thing will come to ground at this particular thing. There is a no use of implementing the particular logic. That is the where the logic will going to be speak like if it is on, it will going to be off. If it is in on state, whatever the input you are giving, it will come to this particular output in. This particular output in it will going to get. If it is in on, then it will going to be off. So then whatever the thing it was stored before the data, the same thing it will going to be discharged like this. So on is nothing but one output you are going to be get if PMOS is on. If NMOS is on, you are going to get as output as a zero. So where the two transistors itself, it is working like complementary. So that is the where the complementary metal oxide semiconductor was came to the picture. Next, it is a foundation for the modern digital integrated circuits. Why? Because of every standard cell or logic gate or memory element or any processor, whatever may be, it was built with the help of the CMOS transistors only. With the help of this CMOS transistors. Okay. Only with the help of this CMOS transistor, the particular all the logics will going to be implemented. Next, with respect to PD, how the CMOS will help to analyze this timing, area, power, or whatever may be. So, how the power consumption we are going to be analyze area, performance, and technology scaling and standard cell architecture. So, these things we are going to be see now much more deeper now. Okay, these are the things. So, MOSFET basics. So, this is nothing but a CMOS, where the combination of the PMOS as well as the NMOS. Okay, next. First of all, if you are going to be speak, this is nothing but a MOSFET. If you think either it is whatever maybe the MOSFET is a PMOS or NMOS. So this is called as a source terminal. This is called as a drain terminal. This is called as a gate terminal. Then what is this body terminal? Why it is important? So this is nothing but a body terminal. If the PMOS body terminal is not connected to VDD, then the latch up issue will going to be occur. Here, what is meant by latch-up issue? Why it is occurring means the always on BJT will going to be formed between here. Like this, the always on BJT will going to be formed while connecting with this particular thing and this particular all the things. Okay. So because of this always on BJT, whatever the gate input you are giving to this, okay, whatever the source input is coming from the PMOS, everything will go to the ground only directly. Okay, there is a no output you are going to be get. Always the output will going to be written as 0. It's not supposed to occur. So that is the reason where the body terminal was introduced and the body terminal is connecting to VDD for PMOS. Same thing if it is NMOS, it will going to be connected for the ground. Okay, these are the things. Here MOSFET stands for metal oxide semiconductor field effect transistor. Okay, effectively it will going to be work as per the particular input thing. And this is the basic building block for all the digital circuits. And MOSFET will going to be work as a switch. Okay, like especially we are going to be called with the example as a water tap you are going to be called. So if you close, the water won't allow, like water won't come. If you open, it will going to become. So mainly want to think like how the MOSFET is working means here will be the drain. Here will like it is a drain and this is the source. Here will be the connection will going to be there. This is nothing but a channel we are going to be called. Okay, like this. It is nothing but a channel. This is nothing but a substrate. Okay. It is a PMOS means N substrate will going to be. It is NMOS means P substrate. Like that it will going to be. So here we are going to be get a gate terminal. This is the source and this is the drain. Where the channel is nothing but a thin sheet of electrons, where that all the electrons are in rest position. They doesn't have the enough energy to move from source to drain or drain to source. And one more important thing for the as a EC engineer, you want to know like always current will flow from positive to negative, what we learn. But the current will flow from negative to positive, not from the positive to negative. So where it was analyzed from the later stages, and that is the way in between the current equation, we are getting like minus ID current. We are going to be call it as a minus ID because we are changing the polarity of the particular current itself. Because instead of like going from, it is actually coming from minus to positive, but we are calculating it as a positive to negative. That is the case. Okay. Next, what is the what is the working principle of this MOSFET is nothing but like when the voltage is applied at the gate, the transistor will turn on and allows the current to flow between the source and drain. That means this is the thing. These are two things is there. Is a channel if you think. So here we're going to be gate terminal if you think like directly. There is a drain, there is a source. Whenever you are giving, we are going to give the VGS voltage between these two things. Okay, positive to this gate and negative terminal to this particular source. Then this channel will going to be established. Then whenever you are giving like VDS, the voltage between this drain and source. Okay, source is positive or negative. Either you can give anything based on that the current flow will going to be decided. Okay, so here you may can ask like always whenever we are giving the VGS, then only the channel will going to be create. No, there is a two types: enhancement MOSFET, depletion MOSFET. In the enhancement, it will going to be occur. In the depletion, already it was pre-defined. Like during the fabrication itself, it was implemented. Okay, like if whatever the electrons is there inside the channel, it want to move means we want to give this VDS voltage. Based on that only it will going to be work. Okay. So why it is called as a MOS also means here what are the gate terminal is there, it will going to be metal oxide then semiconductor. Metal oxide then semiconductor. That is the reason it will called as a MOSFET. Okay. Next, why it is important means the millions or billions of transistors of MOSFETs are used to build the modern chips because a single small mobile as a single device, it's supposed to perform the n number of operations. How it can able to perform? As a single transistor can perform all the things? No. It requires a more number of transistors. For that, the integration will going to be happen in the layer by layer. That kind of the things. Where the transistor size is decreasing as well as the functionality is increasing. Next, this is the basic difference between the NMOS and PMOS. So N-channel MOSFET, NMOS stands for N-channel MOSFET. It will going to be on for the logic one. It will going to be pass the output has a strong 0. the switching speed is more, as well as the smaller transistor size while comparing with the PMOS. Next, the whenever the gate input is 1, it will going to be as a closed switch. It is a 0 means it will going to be work as a open switch. Here, see why I am showing this all the 4 different kind of the transistor symbols. Like if you see the different websites or different authors, they are going to be represented with the different symbols. So all are same. All will going to be work with the same functionality only. There is a no changes in the functionality. Only the representation will going to be changed. Okay, same thing. If you come to the PMOS, so it will going to be on for logic 0. It will going to give the output as a strong 1, and it is the slower than NMOS because NMOS is nothing but a majority charge carriers or electrons, and here the holes. The mobility of the holes is the mobility of the electrons are faster than the holes. So that's the reason we are going to be called the transistor side. That means if this is the NMOS, if you are going to be called this is the NMOS. So for 1 nanosecond, it is coming from like here the input, whatever the output we are getting from the source to drain is like 10 electrons. If you think, if it is a PMOS means it will going to come either 5 or 6 electrons only because the mobility is less. That's the reason we are going to be increase the width of the PMOS. That is the where the transistor size will going to be increase because within this thing 5 electrons is going means here we are going to be increased to like this to 10 electrons. At the same thing, NMOS will going to be remain like this only. It will going to be allow the 10 electrons at the same time. So this is the where the transistor size will going to be vary with respect to the PMOS and NMOS. So the PMOS will going to be on for 0 and NMOS will going to be on for 1. And this is the 4 different representations for the PMOS. I think it was clear for everyone. If you have any doubts, just note it. We'll figure it out. Next, the difference between this PMOS and NMOS is there. So the parameters like, so what are the different parameters we are going to be compare between this PMOS and NMOS is nothing but like one is on condition, when it will going to be on and when it will going to be off. Next is nothing but a speed. Next is nothing but a size and pass the best. I mean, which output it can able to pass it. So already we discussed this all the parameters in the above slide itself. This is a comparison between the both. If you speak with respect to PD point of view, PMOS shell generally occupies the more area because PMOS transistors are larger than NMOS. If n number of PMOS is there in the design means it will going to be impacted for a PD engineer with respect to the area as well as the delay also. Okay, so like this you want to understand with respect to the PD point of view. Okay, always and as well as in the every interview, whenever they are going to be target on this particular CMOS, they are going to be asked you people to explain how does this CMOS inverter will going to be work with respect to the transistor like schematic diagram. They are going to be asked that always in the any either it is a core company or startup or whatever maybe they are going to be target with the CMOS inverter as well as its characteristics and everything else. We'll see this clearly like how this particular 1 or 0 will going to be get and how it is going to be occurring. So CMOS inverter is the most basic CMOS circuit like. So it consists of one PMOS and one NMOS. What you want to tell? Next, operation. Well, coming to operation, whenever your input is 0, PMOS is on and NMOS is off and output is 1. That means it is on. The switch is like closed switch. So here it is nothing but open switch. Okay. So here VDD like 5 volts is nothing but a logic 1. Nothing but a logic 1. This logic 1 will going to be come to here at this particular point. And where there will be one more thing called as a load capacitance called as a CL. It will going to be store that thing as output we are going to be get as a logic 1. Here you want to get a doubt like whether it will come as it is, whatever the 5 volts I am giving, the same thing will come. No, that is nothing but a VDD minus VTH. It will going to become. If you think like VDD minus VTH is like 0.2, the output is like 0.8. But still, as per the noise margin concept, what I explained like previously, is a logic 1 means up to 0.7 it can consider as a 1 only. It is less than the 0.3 to 0 means it will going to be considered as a logic 0 like this. So with respect to that, we are going to be tell like PMOS is passing the strong one. Next operation. So whenever your input is 1, NMOS is off and PMOS is on. That means here it will going to be open switch. Okay. Here it will going to be closed. So here it is a open. Whether it will come to here? No, no way. It will going to be stop here. Then what is the thing will going to be happen when my NMOS is on? So whatever the thing load capacitor, whatever the charge it was stored previously when my PMOS is on, that thing will going to be discharged like this. If everything was discharged, then it will going to be remain with the zero. That is nothing but a strong zero. It will going to be pass here. That is, this is the way you want to explain. Okay. And there is a one more three things is there, regions where the MOSFET will going to be work. That is nothing but a linear, saturation, and cutoff. These are three things is there. You want to explain these three things also. Whenever you are explaining this thing. With respect to this VTC characteristics, voltage versus current, like with respect to that thing, you want to explain like when the PMOS will going to be on, when the NMOS will going to be on. Okay, what is this region is called as? What is this region is called as? If voltage is like 0.1 gate input, 1 is the input is 0, then what will happen? So like this you want to explore. Okay, so this all the deeper things we will see in the course. As here as a workshop, we want to know this basic all the things. Okay, here is the main thing will come to the picture, the power consumption. And here you will get some more idea with respect to how the power consumption will exactly will going to be happen and everything. Okay. So first we will see that what is the power consumption, what are the possible ways why this power consumption is occurring in the CMOS. So power is the one of the important factor, the parameter which we want to consider as for PD, main thing. In the modern chips, everyone is expecting a low power design. That means once if you charge your mobile, it's supposed to come at least for the 12 hours or 8 hours or 14 hours like this. So that means the all the operations internally of that your mobile it's supposed to work, but it's supposed to consume very less power. Then how it will going to be happen? How it will going to be work? So that thing you want to understand. Or else you want to understand the one more perspective, like if you are not using your mobile, if you charge it for 100%, but if you see after 1 hour or after 2 hours, it will going to be reduced like 5% or 10%. Why this particular thing will occurring? Like what is happening here? I'm not using my mobile, but why still the power consumption is happening? So like this you want to think. So here, mainly here we are going to be focused on one thing called as a battery life, heat generation, reliability, and performance. Here we're coming to the mainly the power is nothing but two types consumptions: dynamic power and leakage power. Leakage power also a few times we are going to be called it as a short circuit power. While coming to the dynamic power, so dynamic power consumption when transistor is switching from 0 to 1 and 1 to 0, then the for whatever the power consumption is happening, that is called as a dynamic power. That means whenever you are using your mobile for certain operation, at that time whatever the battery, whatever the power it is consuming, that is called as a dynamic power. So mainly with respect to PD perspective, the dynamic power consumption will going to be occur because of clock toggling like this, like switching from 0 to 1 and 1 to 0 like this. And next thing is nothing but a logic switching continuously. This is the two parameters. Next, factors will going to be affect the dynamic power. That means what are the things which will going to be leads to get a more dynamic power in the design. The first parameter we are going to be called it as a switching activity. Next is nothing but a clock frequency. Next is nothing but a supply voltage, and next is nothing but a load capacitance. This is the four things which will going to be leads to increase or decrease the dynamic power. These are the four parameters can decide what can be a dynamic power consumption exactly. Next is nothing but with respect to physical perspective, what you want to observe, like as the switching activity increases, power consumption increases. If the power consumption increases, the heat will going to be generated. Okay. So as well as the clock network contributes a major portion for this dynamic power. This is the three reasons. See, if you are using your laptop or any electronic device like continuously for hours together, the heat will going to be generated. That is the thing. Why means because you are using continuously, some switching, some operations is happening internally. That is the case. You are going to be you supposed to be understand behind that. So here is the thing, leakage power. Second thing, leakage power is consumed when the even when the transistor is off. That means when you are not using your device at that time also still the power consumption is happening. Why that power consumption is occurring? So that is the thing which we want to analyze here. Next, why leakage is occurring? One is nothing but like modern transistors are extremely small because see, before this much of size is the transistor. If you think now the transistor size is this much. As technology was scaled down, see in the 16 nanometer, if this is the channel, that means like 8 x microns is the channel length, like lambda 8 lambda is the channel length. Now while coming to the 3 nanometer, 1.5 lambda is the channel. So this much of difference is there between the distance between the drain and source. So as the distance between the drain and source, that means the channel length is shrinking. As the channel length is like reducing, the power consumption will going to be more. Next is nothing but as the technology scale down, leakage current increases. Next, with respect to physical design perspective, how we want to see like leakage becomes a major concern in the advanced nodes such as these are the technology like nanometer technologies we are going to be called. And if you think like best example, so nowadays, as a most of the employees, if you are going to be think, if they are going to be run any stage or they are performing some certain operation or they are performing some certain task, then if it is in the intermediate, like it is running in between, if they want to go out or if they want to do some other task, if you think, then what they are going to be do? They are going to be keep their device in the sleep mode. According to her, sleep is nothing but still the device is we are not using the device, but still internally, like whatever the thing is the background, it is working. That all the things also will comes under this leakage only. Whenever you are using, you are monitoring that all the things, then you are going to be call it as a dynamic background. Whatever the operations is happening, what are the things is happening, that all the comes under this leakage power only. Nowadays, the leakage power is more than the dynamic power. Okay. Next. So here we are telling like these are the possible ways we are getting this power consumption, right? So how we want to reduce the power consumption as per PD perspective? As per PD perspective, how we can able to reduce it? One is like multi voltage cells. Next is nothing but a power gating. Next is nothing but a sleeping mode. Okay, this is the three possible ways. Here you may can ask me like what is power gating or multi voltage cell? Power gating is nothing but if this is your design, if this is your design, okay, exactly. So it consists of like 10 modules if you think. Okay, so at this moment, these two modules want to work for me. This module is not required. Any functionality is not required for me. Like if it won't work also, no worries for me. At that moment, with the help of power gating, we are going to be stop the power to this particular module. Then whatever the power consumption will going to be happen because of this module, if it runs simultaneously with this, it will going to be reduced. Okay, that is the way you may going to be tell. Next, multi-voltage cells is nothing but a single cell, that means a single AND gate can work from 0.95 voltage to 1.16 voltage. So those are called as a level shifters you are going to be called, which will going to be scaled down that all the things. So if the 0 point voltage is like 0.95, then the power consumption is different, less coming to fact. Here it will going to be high. How this power consumption will going to be occur or IR drop we are going to occur means V equals to IR. So if this is a metal layer, if you are giving some voltage at here, okay, the wire have certain resistance. Because of these two things, the voltage drop will going to be occur. If you are giving as a 5 volts, it will going to be get as a 4.5 volts. So then the 5 volts is nothing but IR drop. That means like 0.5 volts is nothing but IR drop, not the 5. So like this. Okay. So here I told you like there's a three things. First is nothing but a dynamic power for consumption. Input is switching from 1 to 0 or 0 to 1. That is the first thing. So here charging is happening and directly it will come to the capacitor only, load capacitance. Okay. And when this PMOS, when this NMOS is on, then from here to here, the like logic 1 to logic 0, it is turning because of these two things, the dynamic power consumption is occurring. When there is a short between the VDD to ground, when at a time the both PMOS and NMOS is on, then the short circuit current will going to be happen. So here the both things are almost similarly, but with respect to this, VDD minus VTH. It is the case. Here, when it is in the steady state, either input 0 or 1, then if the dead path was occurred, created bit from VDD to ground, then this particular leakage current will going to be occur. Whatever the input you are giving through the VDD, same thing it will go to the VSS. There is a nothing it will going to be get at the output end. This is the three different ways the power consumption will going to be occur in the CMOS. Next, this is the case which we want to learn. Technology nodes. Okay, so technology node indicates the manufacturing generation of semiconductor technology. It mean a lot. That means, see, when you are using the 180 nanometer technology, then the manufacturing as well as the manufacturing rules and the foundry, what is the design, what is the site and some companies are working with some Armstrongs. That means 0.14 nanosecond they are going to be working. I think Cadence is a company which is going to work with the 0.14 nanosecond. Here, benefits of scaling. That means as a transistor, like as a technology node is reducing, what is the advantages? First, we'll see. More functionality can be integrated into a small chip area. So within this chip area, if you think at the 180 nanometer, you can include the camera module, okay, and fingerprint module. If you think these are two modules, you can able to integrate. But while coming to the 3 nanometer, you can able to integrate here with the what is that thing? Not only the camera and this particular fingerprint, like touch or some other modules also you can able to integrate here as a technology node shrinks. Next, while coming to the performance, the performance will going to be increased because in the 180 nanometer technology, if here is a one transistor, another transistor will going to be here, where this much of wire length is there, speed will going to be reduced by default. But here is the transistor size. If the wire is this much also, this might be the next transistor. Where fast the switching also is going to be happen. That means this is the thing. Before this is the channel length in the 180. But now this is the channel length between the 3 nanosecond, 3 nanometer. This is the where the switching it will going to be occur. Next, lower the dynamic power because lower supply voltage reduces the power consumption because of see here before we are using like plus 5 volts. Now we are using like 0.9 volts or 0.6 volts we are using. As you are giving the less voltage, the dynamic leakage also, dynamic power consumption also will going to be less. Okay, this is the three benefits what we can tell if the from technology node is scaling down from 180 nanometer to 3 nanometer or less than that also. At the same time, challenges also will be there, which is creating the more complicated things to the PD engineer especially. So increases the leakage. Smaller transistor leak more current. That means there is the transistor size. So for within 1 nanosecond, now 10 switching is happening. Because of that, more leakage will going to be. So within this area, we are placing the 10 transistors before. Now we are placing some 1000 transistors. So whatever the power consumption is occurring, leakage power is occurring from the 10 transistors is 10 times more than this particular thing. Like so it will going to be give more than 10 times of this particular 10 transistors. So like this. Next, complexity. If they are closer to each other, the routing conjunction will going to be occur. You want to maintain the minimum spacing between that. You want to make sure that all the things, otherwise the overlapping will going to be happen, or shorts or opens will going to be occur, or functional failure will going to be occur. So this all the things also will come to the picture. Okay. So with respect to that, all the things we want to monitor it. Next, with respect to the reliability issue. That means if more transistor is there, more voltage I want to distribute, more voltage I want to provide to my chip, then more IR drop will going to be occur. Okay. So next EM also will going to be occur. So here most of the students where they are struggling is like what is the difference between IR and EM? IR is nothing but the voltage drop occur because of the resistivity and current of the passes through a metal layer. And with by based on this IR drop, the electromigration is going to be decide like how much duration, what is the reliability of my chip, how long my chip will going to be work properly. That is the difference between the both. Okay. Next, signal integrity issues will going to be occur. Signal integrity is nothing but whatever the information is sending by the sender, same thing with the exact voltage levels, it's supposed to go to the receiver end. That is nothing but signal integrity. Signal indicates the data, integrity indicates the correctness of the correctness. The combination of the both thing we can able to tell as signal correctness. Okay. Next is nothing but like this becomes a more critical in the advanced node. That means as the size of the chip was reduces, so more transistors or millions and billions of transistors will going to be integrated there. It will going to be create that kind of the issues. So there is a problem. Next, so standard cell. So here I am telling like power consumption is occurring. So how this power consumption is occurring? Whether the power consumption will going to be same for all the standard cells or it will going to be differ. If differ, how? If it is the same, how it will going to be same? So this is the cross question we want to get whenever we are going to be learn anything else. So if we are learning something, we want to get that why it is occurring from with if it is there, if it is yes, why? If it is not, if it is no, why? So this kind of question, when you are getting this kind of the thing, then only we are going to be learn. We can able to get some more deeper knowledge in the particular things. Okay. Standard cells or predefined logic building blocks are used during the synthesis and PDE. Okay. They are telling like, okay, here they're telling like predefined building blocks. That means everything was predefined. That means who will going to be define this one? That is the question we're going to be get. You want to get, okay? So there will be a engineer called as a library engineer. Okay, library engineer will be there. So they will going to be decide the functionality of a each and every AND gate. So this kind of AND gates, there will be some thousands of AND gates in your dot lib with respect to the different parameters you are going to be called. For example, what is that parameters? Why it is why I need the thousands of things as the same functionality? That is the question if it will come to picture. So so this is your transistor, right? Sorry, AND gate, right? So to get from input from here to here, if you get a input, at what time you are going to get the output? If it is like 0.1, 0.2, 0.3, whatever maybe. And here, for after each, how much time it is taking to change from 0 to 1 switching? From one input to another input, how much time it is taking? So this is nothing but input transition you are going to be called. This is nothing but output load capacitance. Here it will going to be there. Charging and discharging will going to be happen at here end. So this is the where it will going to be represented in the matrix format. So this is the transition. So this is the cap we are going to be called. If my transition is like 0.1, if my capacitance is like 0.1, this is the delay. This much of time it will going to be take to get an output. If my transition is like 0.2 and my capacitance is still 0.1, then this is the x2 delay, like 0.3, x3. Now here, with 0.2, with 0.1, y1, y2, y3. So like this. So here, with respect to this case, there will be one transistor, that means one AND gate. With respect to this, with this one, there will be another AND gate. With respect to this one, this combination will be another AND gate. Like this, some thousands of AND gates will be there. So then you want to get a cross question, like when to choose which one, how this will going to be identifying. Then there you are going to be give some inputs to the tool, like with respect to some constraints you are going to be called, some requirements. Based on that, your tool will going to be fetch, which will going to be met your requirements. Like this is the use of this automated tool, like EDA tools. Directly it will going to be fetch from that particular file. You here, you no need to tell like this is the shell you want to take, this is the thing you want to take. Just you want to give the inputs through the tickle format or through the through the command format. So based on that, it will going to be try the tool itself. It will going to be fetch the things. So this is the overview of this your standard cell, how it will going to be look. Okay. Next, what exactly my standard cell is going to be consist of? Like my standard cell library will consist of. See, if it is there, so first thing is nothing but a functionality. If I give as a 0, 0, what is the output it want to come? The functionality information will going to be present. Next, delay. If I give here as a 0, 0 at 0 nanosecond, at what time my output is coming? That is nothing but a timing information. Okay. If I'm giving 0, 0 input, what is my power consumption? 0, 1 input, what is my power consumption? See here. If I'm giving next input also 0, it won't be much power consumption because there is no switching activity. If I'm giving here as a 1, from 0 state to it's supposed to increase, go to the one state. Here some more power consumption will going to be happen. Like 1, 0, 1, 1, like this. So the power information also will going to be present. Next, cell width, cell height, pin location, layout information. That means in the PD, you are going to be look the standard cell like this. That means this is the where the standard cell will going to be look. This is your AND gate. Actually, these are two inputs. This might be one output. This is nothing but a site rows you are going to be called. Okay. So this is nothing but VDD. This is nothing but VSS type of thing. Here, this is nothing but a height of your standard cell. Okay. So this is nothing but a width. Here, height is fixed. Or it might be have double height. That means if this is the site row, whatever the distance from here to this site row to this site row, same will be going to be here to here. Okay. But width will can able to vary. Either my width can go up to here or up to here or whatever maybe. Okay. So this is the thing. And pin location. Where is my pin? Like what is the name of the pin and what is the label it consists of? How many input pins is there, output pins is there, and everything else like this. So this is nothing but layout view we are going to be called. What are the different examples for the standard cells means? It consists of the both sequential as well as combinational. Like it might be inverter, buffer, NAND gate, NOR gate, or flip flop or multiplexer, whatever may be. With respect to the physical design perspective, what you want to observe here. So as you are taking the RTL, you are with the help of the standard cells, you are going to do. So where the standard cells will play the vital role for the PD engineer. So during the placement stage. In the placement stage, so if this is the core area, this here the standard cell is going to be present until the placement. Then this all the standard cells will go on place here. So in this stage, it will going to be impact. Okay, like this. Next, during the routing also. So between the two stances, it's supposed to be connect now. So there also it will going to be impact. So this is the way the standard cell will going to be. You supposed to be understand about the standard cell with respect to this format. With respect to area, power, sorry, not area, functionality, timing, and power. These are three things it can able to do. Okay. Next. See, once the CMOS model is done, then we'll switch to this particular tool. Okay. So there will be like overview for your ASIC flow. Just if you complete with this ASIC flow, then we'll switch to this particular tool and we'll explain that all the things. Like today we are going to be see the overview of the tool, like how to invoke the tool, what is this tool, why we want to use it, okay, and what are the various options will be available to see the design in a different formats and everything else we will going to see today. And exactly the explanation of the code, what are the scripts I have, as well as the whatever the things, how you can see that each and every individual blocks and all, we'll see tomorrow with respect to stages. Okay, next is nothing but like ASIC flow. Okay, before that, I told you I'm going to be, I will explain you this which is best among the NAND and NOR gate, right? So while coming to that, so what is the logic? What is the Boolean expression for the NAND gate? A dot B whole bar. So there is a two ways while drawing the schematic by using the transistors. PMOS parallel for AND operation. Okay, next NMOS series. Okay, like it will going to become as a series for same AND operation. Next thing, PMOS will going to be like series for OR operation. For OR operation. Next, NMOS will going to be series like parallel for OR operation here. Like see here, That is the where the combination of the PMOS and NMOS is called as a complementary metal oxide. See, with respect to the designing and implementing how it will going to be connect also is complemented that both. It is not similar. So with respect to this, I will draw the transistor thing here. With respect to this, I will explain between the both. Okay. So if this is the PMOS for the NAND gate, where VDD will come to the picture. Okay. From here, there will be a NMOS. PSS, here will be the output, here will be the, sorry, these two are nothing but a gate inputs. Okay. A, B, you are going to be called. Here also I will going to be called as a AB. Here I am going to be get output. Okay. Same thing. If I think here with respect to the NOR gate, A plus B whole bar. That means PMOS is in series. Like this. So below it will going to be parallel. This is nothing but NMOS and this is your one more NMOS, which will going to be parallel. Here will be the ground will be there. From here you are going to be get the output. So see here, if as your PMOS, if the truth table, if you think for the both cases 0 0 0 1 1 0 1 0 1 1, 0 0 0 1 1 0 1 1, here 1 0 will going to come 1 1. As per already I discussed, like PMOS will going to be on for logic 0. Here it will going to be on for logic 1. So when my input is 0, whatever the VDD is there, it will come to here. That means I will get strong output. And one more thing, if here I am giving as a 1 has a voltage, here I will get only the 0.7 or 0.8 because VDD minus VTH only I am going to be get here. Okay, that is the first case. See here, the drop either it will be in this path or this path is nothing but same. The same resultant will going to be get if you are going to with these three combinations. But if you compare these two combinations, one, here you are going to be get the output as a 0.8. Then here again the 0.1 or 2 will going to be lost. Here you are going to be get like 0.7 or 6. So the voltage level also will going to be drop. As well as here to here it will take 2 nanoseconds, means here to here it will going to be take one more 2 nanoseconds. So overall after the 4 nanoseconds you will get the output here. But that is not the case here. Within the 2 nanoseconds you are going to be getting. That is the where NMOS is faster than the PMOS. That is the reason always they will prefer NMOS. Okay. As I told you, I'm going to be explain. So I explained about this thing. Now we will go to the ASIC flow. Okay. So in the beginning, we discussed about the chip design life cycle. So where here you are going to be see like some more deeper into that. Exactly what is this chip design life cycle and how this chip design life cycle will going to be occur and everything. Okay. ASIC stands for Application Specific Integrated Circuit. Okay. Based on the application as well as the specifications, we are going to be integrating the circuits by using the transistors. That is the generalized meaning of this application specific. And an ASIC is a chip design for the specific application. That means based on the client requirement, based on the customer requirement. By using this ASIC flow, we are going to be implementing the chip by using this ASIC flow. So what are the applications might be like mobile processor, AI accelerators, and network processor. These all the things will come to the picture. Okay, next. Here, this ASIC design flow is the complete process of converting a customer requirement into a silicon chip. We are going to be tell like from customer requirement to silicon chip. We are going to be we will get from this single ASIC flow only. Okay, so now this is a basic ASIC flow which you want to know. So first of all, in the most interviews, whether it is a product or startup or any service or any company, wherever you go for any interviews, first thing they are going to be asked the PD engineer is nothing but ASIC flow. Mainly they are going to be asked only the backend flow, which will come from here. Actually, if now we want to explain from here, but before is like from floor plan to this is the stages which we want to explain before. Okay, so and this all the things before it is coming under the front end. Like this is comes under the front end. Now in between these two things is there, we want to speak. Okay, and has a, whether you are a PD engineer or DV engineer, whomever maybe, you want to know like at least the overview of each and every stage, what will happen, what exactly will going to be do there. Not like internal logic or internal skill set, but what is happen on the overview point of view want to be explained as a as you are going to be entering into VLSI industry. Okay, so now we'll see that all the things. First thing, specification. What is this specification exactly stands for? So specification is nothing but it's the starting stage of your chip design, where you are going to be understand the customer requirement and performance target, power target, area target, and technology node selection. This is the three things. Here, for example, see each and every year the iPhone model will going to be changing, like 17, 17 Pro Max, like this it is coming. No, like what is the changes is happening? So where they are going to be changing with respect to performance, power related thing as well as the area related thing. That is the customer requirement. He will going to be tell to the person. So the requirement, for example, in which perspective they are going to be tell. So that might be like my design supposed to work with the 2 gigahertz and it's supposed to consume the power less than 5 watts and it's supposed to fit within this area. That means if this is your motherboard, if you are going to be think in your mobile, for example, in your laptop, so they are going to be tell like I have only this much of area to place this processor, to place this chip. So design me a chip within this area with this particular specifications, with this particular requirements. So as a PD engineer, you want to work on this. As a DV engineers, they want to write a logic which will going to be fit properly within this area only. Like this, the specification will come to the picture. Okay. Next. So the design specification is whatever one documentation they are going to be to this architecture team. Okay. So in this architecture team, what they are going to be do like they are going to be draw some architecture. How we are going to be draw some blueprint of our house before constructing. Like that, the same thing. So this is the case. This is our chip will going to be. So this much of area they give. So this is the height and this is the width which they was given to us. Like that, they are going to be decide. Next. So here, based on their specifications, they are going to be divided into separate modules. So this is the P1 module, like this is the P2 module, and this is nothing but a P3 module, P4, P5. Like this, they are going to be divided, and they will going to be decide like where the memory planning will going to be do, where where the other blocks supposed to be placed. This all the things will going to be planned there. Okay, architecture team will going to be tell like that means planning indicates this all the things is required. They're not telling here like exactly these things we want to come in this particular location. Here they're telling so this many blocks supposed to be placed in this area only. That is the thing they are going to be given. Next, for example, CPU to ALU where it want to place, where the cache memory block you want to place, where the memory controller you want to, where the bus interface like SPI or UART, some protocols and all, everything is there, no? So this all the things where it want to, like how many things it want to fit within this thing, they are going to be decided in the architecture team. Next, once it is done, then we are going for the RTL, where the RTL team will take the document from this particular architecture team and they are going to be write the code in the register transfer level. Okay, either they are going to be write this logic in the Verilog, system Verilog or VHDL, whatever may be. So like engineer will going to be like DV engineer will going to be describe the functionality of the design by using Verilog or VHDL or SV are going to be tell. Might be they are going to be use a procedure or combination, whatever maybe they are going to be used and they are going to write the functionality for the particular blocks. And here as a result, and we will get the output as a RTL code. So for which functionality they wrote this RTL, whether that functionality is working properly or not, whether it is performing that functionality properly or not, we are going to be verified from this. This is nothing but a functional verification we are going to be occur. So as input is like RTL code. Here you are going to be use the thing as a UVM, universal verification methodology is the thing. Okay, it consists of some thousands of lines where it will going to be verify your design with respect to the each and every combination of vectors. Here, vectors is nothing but input patterns. Okay, next. So, by using test bench creation, simulation, and functional debugging. That means if any errors will come, again they will try to debug it, find and fix the debugs before the synthesis itself. So, from this RTL team, we will get a complete, neat, and clean RTL code. Okay, with the error free. Next, in between the DFT will come to the picture. Actually, synthesis we want to speak first. Synthesis. Synthesis is the process of converting this clean RTL Verilog into a gate level netlist using the standard cell libraries. From where we'll get these standard cell libraries? From who we are going to be. I mean, those are foundry people who we are going to be manufacture our chips. Okay, from them we are going to get these libraries and everything else. From that EDA tool, Windows and everything. So from them we are going to get this. By using that only we want to implement our chip. So if we are implementing by using only their rules and regulations by following everything, then only it can be manufacturable in their fabrication unit. If not, it can't. It will going to be end up with a failure only if they fabricate also. Next, in the synthesis, we are going to be taking the input as a RTL code, HDC constraints, and library, and few more things is there, such as like technology file. We are going to be called a few cases. We are going to be called it as the NDMs. We are going to be called our MCMM, some dep file of the fourth, like some other examples also we can able to speak. And what are the outputs we will get from this synthesis means gate level netlist, timing reports, area report, power, and rest of the all. That means here how this RTL is converting into gate level netlist, if that is the question means there are also certain stages is there. So that is nothing but translation, optimization, and mapping. What is translation? What is optimization? What is mapping? These all the things we will see in the tomorrow's workshop. Okay. Next is nothing but a DFT. Once a gate level is we get as a gate level netlist as output. In this gate level netlist, first the DFT engineer will find what is the count of sequential components. So before the DFT, the sequential component will look like this: input, clock, Q bar. Then once the DFT logic is added into this particular gate level netlist, then same register will going to be convert like this: input, same clock, scan input, and scan enable. Output, Q bar, scan out. So where by whenever the scan enable is high, then we are giving the certain input here. We are going to be verify the functionality of this particular block after the chip was fabricated. This is the where the DFT will going to be DFT logic will going to be inserted in the design. So how this will going to be inserted in the design? By using the various techniques called as a scan chain insertion, BIST technology like built-in self-cache or JTAG, or many techniques is there. So these are separate engineers will be there. We no need to bother about this DFT and everything else. Okay, as a PD engineer. So these is about this up to synthesis. Next, if we go for the core planning, exactly the PD was started here. You want to define the chip structure, whether the chip supposed to be look like this or the chip supposed to be look like this. That means, so before this, there is one more stage is called as a partitioning. We are going to be called. Okay, that means this is your chip means. So this is the where your block will supposed to be. This is the one more block. It will going to be like this. That means what I'm telling like some like structures it will going to be give. Based on this structure in the during the floor plan I want to implement here. Okay, with the area. Next, here we are supposed to define the die area, core area, macro placement, and IO placement, as well as the initializing the chip. Here, you may can ask like, what is this macro placement? What is this IO placement? How we are going to be define this particular core area, die area, and core area we are going to be defined based on the standard cells. How much? What is the area of a standard cell? Plus, is there any macros or any blockages which are predefined? Predefinedly, you are leaving some any space in the chip. That all the information divided by your utilization is the factor. Okay, next. Then die area. Die area is nothing but a core area plus what is the offset is there as well as the IO spacing. between them. So like this, you're supposed to define like macro placement. If this is your chip, okay, this is your core area. If your input is there, so whether you want to place the macro here or here or here, you're supposed to be decided. Actually, we won't prefer this area. It will going to be create the timing as well as the conjunction related issues to us. So most preferably, we will prefer this area or this areas or at the boundaries of the core area. We are going to prefer most preferably. Okay. In the worst case, if that is a specification, there will be we want to follow the certain techniques to place that things in there in the center also. It can be also possible, but it will be more bit more complicated to things. Okay. Next, once it is done, initial chip layout structure is the input for your power planning. So now power planning. What is my power planning means? As we are taking this particular structure of the floor plan, we want to decide the power planning. So the major input for the power plan is nothing but UPF, where your design, this is your design, right? This is your core area means the entire core area is working with a single voltage or multiple voltage. Like it we can able to design this voltage will going to work with 0.9. This voltage can work with a 1.16. This voltage can work with a 0.6. Like this also we can able to implement. This thing we are going to be representing in this particular UPF. Okay, next. With the help of this thing, we are going to be decide these things. Next, from this, whatever the core area is there here. So this is your die if you think. So here we are going to be design the rings. We will going to be call it as rings. The ring will going to be get a power from the external world. This is nothing but a mesh you are going to be called. Mesh also will going to be vertical as well as a horizontal thing like this. So this thing will go on connect to here and might be this thing will go on connect to here like this, and internally there is like VDD VSS rails will be there. That means what I'm telling you here, like here there will be one more parameter called as rails in between them. So this rails directly connected to your standard cell. This mesh it won't connect. Power will come from external world to this ring to mesh, mesh to ring, mesh to rail. From this rail, your standard cells will going to be get the power. Is the case. Clear? Next. So here mainly we are going to be face the IR drop as well as the EM issue. Placement thing. Next we are going to be see the placement. So what is the placement? Here name itself it will going to be indicate that placement. That means placing the standard cells in the core area. That is the meaning of that. Okay. So here we are going to be place the standard cells at here. Within this core area, we are going to be place what are the standard cells is there at this particular point. Next is nothing but a CTS. We are going to be give that we are going to be distribute the clock to this into the registers. So like this, the routing, STA and sign off and signal integrity things will come into picture. We'll see this all the things deeply tomorrow session, tomorrow's workshop. So now we'll jump into the tool. Just I will give you that what is the tool and how this tool will going to be look and what are the tools is there in the EDA like in the under the Synopsys vendor. Everything I'm going to be explain for you quickly. Okay. So is there any doubts regarding until now with respect? I think you have some you got some clarity up to this ASIC flow. So for the PD, the open source tools are won't work properly to show that all the things to perform that all the analysis actually. Okay, that is the reason we are using that thing. If you get, you can able to try, no worries. Who told the front end will going to be vanish? Okay, fine. And finally, we'll give that mic access to you people. That time we can able to speak. Can you give the mic access to them if you can? Mic access to them once. Let them ask the questions. Parallel, I will start the tool. Yes, few open tools is there, but there we won't get that proper like PDK files and everything else. So that is a problem. First of all, discuss about the tool, and later we'll see that. So what is the tool and how that what are the different the tool we work on everything. Okay. So first of all, here we are going to be use the tool called as a fusion compiler. Okay. Here we are going to be use the tool called fusion compiler. So here we are going to be use the tool called as a fusion compiler, where the single tool will going to be do the both synthesis as well as the PNR. It was integrated with synth as well as the PNR process. Okay. Here in the before the fusion compiler was introduced, at that time they here the in industry they are going to be use the two tools. With respect to the Synopsys is like with respect to the Synopsys, there is a two tools called as a design compiler as well as ICC2, where we are perform the synthesis in the design compiler and we are performing PNR in the ICC2 tool. So, but why it was introduced? Like, what is the drawback among the both, and why this particular tool was introduced? So, what is the problem behind that? Is like, as a as the front end people are not aware of this particular PPA. They are not thorough of this with respect to this PPA. So, where once they are going to be give some particular net list to us. So once we implemented that all the things, we are going to be end up with like, so the design is not good, like it is not meeting our timing requirements, that all the things, that all the issues will come to the picture. Okay. To overcome that things, the tool was introduced called as a fusion compiler tool. Okay. In this, as we are taking as the RTL as the input, we are going to give the tool has a, that means GDS2 has a output. That is the case here. And one more thing is like whenever you are going to be give the data from design compiler tool, you are going to be extract and you are going to give for the ICC2 tool. So then it will then there might be a loss of information also. So this issue also will going to be occur. So like this to avoid this all the kind of the issues, we are going to be that means in the nowadays they are going to be introduce the tool called as fusion compiler, which will going to be evaluate for within the 1 or 2 years, it will going to be most used tool in the industry. That is the case. Okay. In this particular thing, hello ma'am, can you give the mic access to them? Hello. Hello, ma'am.
Hello. Yes, yes, sir.
Yeah, can you give mic access to them?
Okay, okay, sure. Are you not showing the tool today?
Yeah, I will show. Parallel, I will show that.
Okay.
Like
Yeah,
parallel, I
I'm
will
unmuted.
discuss this thing.
Okay, guys, you can unmute and you can talk.
Yeah, one by one, please.
Hello, can I
Hey,
ask a
Google this side,
question?
sir. Yeah.
Sir, actually, I have going through this training program, physical design domain, sir, and right now I am looking for some real project-based opportunity. So, will you provide some live project-based things in internship like this?
Yes, we will provide that. Ma'am, can you answer for this?
Yes,
Hello,
we
ma'am.
can plan if there are group of students who are interested only for projects, we can plan that also.
Is there any charge for that?
Yes, of course.
How much?
We will let you know. We need to decide that because
And
we
what's
don't have.
technology like the project? Can you elaborate more like which technology and what kind of the project and block size and all?
Already will answer for that.
Sorry?
Our
Yeah,
trainer will answer.
here we have that. Yeah, here we have that vendor called as a Cadence EDA vendor. So where we are going to work with the 7 nanometer technology here. Okay. So we have the complex designs from a simple design to complex designs, which is working on the real time with macro integration and everything. So based on the application, like based on the requirement, we can able to provide that. If you require a complex design, also we can able to provide. Or if you require a simple design to understand the flow and everything, also we can able to provide it.
I have a
Okay.
few questions, if you please allow
Yeah,
me.
please.
Yes,
Yeah,
the
please.
first question is that what type of finite state machine is used in the memory logic? Like in your previous presentation, you mentioned the use of finite state machine in the memory elements of the CPU. So either it is like melee or Morley or overlapping or non-overlapping. So which sort of finite state machine is used?
So see here, like there is a specific application for that. See has PD. Yeah, give me a second, guys. Give me a second.
Sir, could you share the PPT, sir? To the mail. Okay, can you share it, sir?
Sorry, man. Like, what is your question? Like, which model you
Sir,
want
can
to
you,
use? FSM model.
Yes, FSM model.
Guys,
can you share
please.
the PPT?
Hello. Please mute yourself.
Sir,
Hello. Please mute yourself. And what is your question? Like, in between I stop.
Which
Like, you
type
are asking
of
about the melee, which
like
can be
which type
preferred.
of
See,
finite state
based on,
machine is
yeah.
used?
See, this which kind of FSM they are going to be decide. This will going to be take care of the architecture team actually. Okay, because of from the specification team, they will get some like this is the area target, this is the power consumption target, this is the delay target, like performance target you are going to be tell. See, if you coming to the melee, what melee will going to be tell? You are going to be tell like the output will going to be depend on what? What basis the output will going to be depend on the melee and Murray? One is like
On
with
the,
respect to state
on
as
the
well as the transition. Next is
yes,
nothing
current
but only
state
with
and the
respect to the
inputs.
state. Yeah. Transition as well input that thing, no? So like if it is depending on the both, then the delay will going to be increase. If it is depending on the only single thing, then the delay will going to be reduced. And one more thing in the melee, the one state is extra than the Moore. Sorry, in the Moore mission, there is a one state extra than melee mission, right? So here, if one state is extra means one register will going to be increase. If one register will increase means the delay will going to be increase. Indirectly, the area also affecting as well as the power also affecting. So like this, they are going to be think as per the application and they are going to be use it.
Okay,
Clear?
and my next question is that how many transistors can come on one layer? Like how we can judge that there will be 9 layers, 10 layers, or 15 layers, or what maximum number of transistors can come on one layer?
That is will going to be depend on your core area, man. Based on your core area, what is the width of that means what is the width of the cyto and what is the height of the cyto will going to be different based on the technology node and core area. Based on that, it will going to be placed. Okay, you can't tell like within this particular 10x microns means 10 transistors like that we can't. See here, we won't place with respect to the transistors. Here we are placing with respect to the standard cells. Okay, where the standard cells are nothing but like predefined blocks as per the PD perspective you want to think. Okay, that mean what I'm telling like, see, you are able to see my screen, right? This is your cytro means here you are not placing your transistor this thing. Just here you are placing this as a block. Okay. So where this block consists of, it might be 2 transistor, 10 transistor, 20 transistor, whatever may be. Here it will follow the certain rules and everything, and it will going to be placed here. So this cytro length will going to be depend on based on the what is the core area we are going to be choosing. If your design is like big, so at that moment here this much of thing means here the core area will going to be long. If your design is like very small, then the core area will going to be less. Here only 1 or 2 transistor will going to be placed. So like this it will going to be vary from thing to thing. Like core area to core area as well as design to design, it will going to be vary. Understood?
Yeah, I understood. So
Yeah.
another question was that the technology nodes are not finalized when we are designing the front end. Like if we are writing the Verilog code, we are just writing it for the standard or universal, regardless it is for 180 or 130 or 3 nanometer. It will be decided at the stage of synthesis where we can get the netlist or timing and power, etc.
Yes. See, but here I explained you one thing during the specification thing. Once again, here I explained you about the specifications, right? Specifications. So yeah, I think this is a slide. So here the client itself, the customer itself, he will going to be give you like, okay, what is the customer requirement, what is the performance target, power target, area, as well as which technology nodes, on which technology node you want to use it. So based on that only he will going to be deciding. So that technology node, based on that, what might be the area a single standard cell will go, transistor will going to be occupy everything. The architecture team will going to be think and they're going to be design and they're going to be arrange the blocks at that time only. Like how many components is required, how many is not required, like that all the things will going to be take care of there. Okay. Understood?
Yes, I understood. Thank you.
Is there any other specific doubts?
Sir,
Yeah, please.
sir, I am a beginner, sir, but which
Okay.
front end or back end, which one is I will choose, sir? Which one is easy?
Okay. See whether you are interested in coding or whether you are strong in coding.
No, sir.
You are you are a bit not strong in coding means then better choice is like you can choose the PD. Not only
Okay,
PD,
sir.
see comes if you comes under the PD, there will be 3 things. PD is there, PV is there, sign off and ST engineer. So you can able to switch to any within these 4 job roles also. If you are not strong in the coding part, if you are strong in the coding part also, there also explain like RTL, verification, DFP, this all the things.
Okay, sir. Sir, if
Yeah.
now how to concentrate physical lesson, sir? Which is subject I learn more?
See, first of all, you want to learn the physical design means first you want to go through all the digital electronics. Okay.
Okay,
then
sir.
you want to go to the
Okay.
Verilog module basics, then you want to come to the PD. So where this all the things we are predefined, okay? We'll
Okay,
help
sir.
you with respect to this. Once if you join course, we are going to be figure it out what is your strong area, and we are going to be explain with all the things for you people. Okay, you no need to worry
Okay,
with
sir.
respect to that. If you tell like what is the area you are strong, we can able to explain. See, these are where we are going to be invoke the tool. These are where the tool will going to be look. Just it is a synthesis part. See here, this is the way my all the RTL codes are converted into this kind of symbols. So what is this symbol? Here you can able to tell like it is like some shell
Could you
name called some random name it was given. So you want to see like what is there internally. Then how you can able to see with the help of this tool you can able to see like this. So what is there inside
okay,
of that particular also you can able to see. Yeah, please.
Could you please turn off the real-time text, sir?
Ma'am, can you do that? Hello? Excuse me, ma'am. Yeah, can you turn off that real-time texture? Okay, ma'am will do that. Okay. So this is the way you can able to see this, but all the logics. So here, what is the main objective here we are telling like, so this is a code. For example, if you are speaking about here, this is the RTL code which we are using. Okay. Here
Sir,
some
good evening,
RTL
sir.
code.
Can I ask some question?
Yeah, please.
I'm a final year student, BE Electronic Communication Engineering. I want to
Perfect.
get started with my career in VLSI design, but either
Okay.
I don't know what domain is fit for me in VLSI design.
Okay.
Can you suggest and
So that
give me
is
some idea?
no like so that is the way. See, once if you listen this complete design,
Okay.
okay, like complete workshop for tomorrow also, then you are came to know you can get some idea on the PD. Okay.
Okay.
Next,
Okay.
whatever the see like here, whatever the thing you are seeing here with respect to this logics. So this is the by using this particular techno like Verilog and all, this is the where they are going to be write the logics in
Yeah.
the front team. Your
Okay.
strong area, if your strong area is like coding, you may can come to this particular front end also. It is also good.
Okay. Okay.
So here
Okay.
nothing we can tell like this is this is best and this is not. So both
Okay.
are have their own priorities. Okay, with
Mm-mm.
respect to the career and everything, growth and everything will be both are good based
Mm.
upon where you are expertise, whether you are expertise in the coding and logical thinking, or you are not expertising with that means then you can shift to PD. If you are good with coding, you can shift to front end also.
Okay. 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 Thank
Like that you want to think. See, this is the logic code which we used as RTL, but here this is the where it was implemented to us.
you.
So
Okay.
which model is implemented to like what? So this all the things if we want to see means we can able to see this all the things. And here see
Mm.
we can able to see the schematic of this particular thing. This is the schematic of the particular selected block. So like this you can able to see for all the things also like what is your schematic of the entire design. So like PD is nothing but which you can able to see visually what is happening exactly there. Okay, that is
Okay.
the thing you can able to see in the PD. So
Mm.
by taking one block as a reference, see this is the block which the RTL team will going to be get as a front end engineer. You want to write the logic. You want to know what will going to be happen internally with the help of these inputs and these outputs. You want to write the logic. That is
Okay.
nothing but a front end team, where the
Mm.
PD team can implement this all the logic whatever the front end is writing. It will going to be implementing in this way. Okay,
Okay.
like this you are going to be called.
Okay.
Sir,
And
Based on your
with the
expertise
in
area and
VLSI
you
industry, uh,
yes,
okay. In VLSI industries, what
continue the
they
question.
will expect.
Your
Yeah. Can I
your voice
proceed?
is bit your voice is breaking like yeah, can you proceed?
Okay.
Proceed once.
In VLSI industry, what they will expect from us as a student.
So that is the way from the starting section I'm telling, like as a fresher with respect to PD, you want to be expertise in this thing. You want to expertise it in this particular areas I'm telling, like see for which job role you are applying. Based on that, it will going to be vary. Okay. If you are applying for the front end role, you want to be expertise in the Verilog UVM and all. If you are PD, back end flow as well as the ticket scripting like that. So based on the job role and what is the where you are going to be choose. Based on that, it will going to be vary for you.
Okay. Okay. Thanks.
It is
Sir,
not the
what will
case like you want to choose this one. Yeah, please.
what will be the roles in front end? And if we want to go to the design verification, what are the conceptual things we need to more focus on?
Yeah, with respect to verification, ma'am will guide you people. So with respect to backend, I can guide. Ma'am, can you clear his doubt?
Yes, for design verification, first of all,
Hello,
we
ma'am.
need to be very, yeah, am I audible?
Yes, ma'am.
For design
Yes,
verification,
ma'am.
first of
You are
all, we
audible.
need to have very good knowledge in digital electronics, total practical knowledge we need to have in digital electronics. Then RTL design using Verilog HDL. So you need to learn Verilog HDL and functional verification. You need to learn system Verilog and UVM for functional verification. These two are very advanced languages where we can verify the design, RTL design. Okay. After these four, you need to concentrate mainly on projects and protocols. Protocols are most important. As you are a fresher, you can start with UART, I2C, ABB, AHB, AXI protocol. You need to design in Verilog HDL and also you need to verify using system Verilog and UVM of these protocols where you need to develop the test cases, test plans, you need to create test functionality, you need to verify. So your goal should be verifying the test cases as a verification engineer. Okay. Apart of this, you need to learn scripting. Okay, these are the shell scripting is fine or Perl scripting, Python, any scripting is fine.
Okay. Assertions.
What?
Assertions.
Assertions will come. It is just a topic in system Verilog. Assertions, coverage, all these are topics in system Verilog and UPM.
Okay.
Sir,
And could
this,
you suggest me any
Yeah,
project
please.
for front end engineer?
Come again.
sir,
Could ma'am suggest some project for front end design?
See,
He
like
is
with respect
asking
to all
you
the
to
front
suggest
end
projects for backend.
sir, is
backend.
AI will
See, like
destroy front end, which is coding part, sir.
so this like that is the thing where the AI called as a cerebrum. Cerebrus is the AI which is working by Samsung, but it will take more years. It won't impact. Okay, just it will try to optimize the things better than the humans. That's it. Okay, still also the quality of PD engineers are required to analyze that all the reports and to take the action as well. That means to take the next action, how to fix that all the things. It won't destroy any of the VLSI industry. AI it won't. Okay, it will come. It will going to be cover the certain margin only, not completely. If you are a good and with
Okay,
you are a good VLSI engineer, your job it won't happen. Anything.
Ma'am, will
okay.
AI affect design verification part?
Actually, there are some AI agents which are already designed by the product-based companies. Even AMD has designed 20 plus AI agents. By using AI only, they are going to develop the test cases, test plans, everything nowadays. Okay, so definitely AI won't replace everything. Okay, you know there are a lot of mistakes it is giving even by using the AI agents. But anyway, you need to upgrade your knowledge whenever you go to the industry. You need to upgrade your knowledge every time. Okay, it comes with your experience itself. No need to worry that AI will replace it doesn't replace totally, but you need to upgrade your knowledge every time according to your experience. You need to learn more projects, PCI, USB, Ethernet, DDR is most important. So if you focus more on your work, it never replaces.
Okay.
Sorry,
Sorry, ma'am.
Give me
I
the
just
name
wanted
of
to
the
ask, ma'am.
project.
Could you repeat? Could you
Hello.
repeat the projects, ma'am? Sir, can you hear me?
Yes, for design verification, you need to work on mostly protocols like UART, I2C, APB, AHB, AXI protocols, and projects like RISC-V processor project is most important, the computer architecture. DDR is
Yes.
most important, memory controllers, DMA memory controller, and
Yes.
you can do any type of projects, no problem, image processor related projects or any projects you can do, but mostly we need to concentrate on RISC-V processor because it is a computer architecture dependent based project. Intel, Qualcomm, AMD, Samsung, Synopsys, ARM, these they mostly focus on these type of architecture based projects.
Okay, ma'am. Thank you.
Ma'am,
Sir,
can you tell
is
me the
join
name of the tool that we are
any
using now?
online process?
Yeah, please.
Hi, ma'am.
Ma'am, are you offering any free online courses?
Yes, yeah, please.
Ma'am, will
Are
be
you
there
offering
a
video
workshop
courses?
on design
Guys, one
verification?
second. Whether my voice is audible?
We have guys. I am sharing my screen. Just a second.
Hi, sir.
If you want to know more about
Can I stop sharing?
our, is the screen visible?
Yes, ma'am.
If you want to know more
Can I
details
stop sharing?
about the hello, if you want to know more details about the training and courses, please visit our website. In this website, everything is available. The course details, what are the job-oriented courses. If you are a working professionals, you can choose the career switch programs, and there are internships, embedded systems. And newly we have uh, started embedded systems. Literally, you can see the course curriculum. You can even compare the curriculum with ours and other institution. You never learn these things about bring up Linux kernel, device drivers, Yocto project, Capstone project. You never learn these advanced projects in embedded systems. Even you spend lakh of rupees in other institutions. Okay, but we have added these based on the trainer. The trainers are very expert, high level experts there in Provilogic who are working in different companies, product based companies. So those trainers are very close to us. So that's why we design this curriculum in a very high level. Normal trainers, normal institutions, they don't provide this much high level training in for BTech students. Okay, but as we are having good communication with the industry experts, we designed this training program with these projects. Actually, embedded systems means it's a board bring up, not just learning embedded C like that. Okay, if you are focusing embedded system, this will be the best course. If you are focusing for VLSI, we have a design verification and also physical design. Everything is mentioned here. The course curriculum. If you see the design verification, what are the modules we are going to cover, and what are the if it is a PD, what are the modules we are going to cover? Everything are mentioned here. Please go through this. We have both online and offline trainings we are providing, and also we are providing the best placements for the students, both in online and offline. We are having best placement rate, and also we are going to start the service-based company in the next 2 months, where we are providing the placements to our students in our company itself. So we are planning, we already have started, and we are going to get the projects actually. So in next 2 months, we are going to hire our students only into our startup company. Yeah, that's we are mainly focusing much on placements for freshers, because for 2025, 26 passed outs, it is really difficult to get the placements in industry, and also a lot of people are struggling to get the placement. But we are starting the service based company where we can take our good trained students into the our company. Okay, so that's what our main goal. So placements wise, you no need to worry, and training wise also you no need to worry. Our trainers really they focus more onto the students. They especially focus on whether the student is understanding the concept or not. How we need to tell to the students, how we need to explain to the students to understand in a easy way, like that our trainers are focusing. And also you will be getting the LMS portal. If you see, this is our LMS portal. I can just show you, just give a minute. Please mute everyone. This is our LMS portal where you are getting the course enrollment here, and the materials and assignments, or we are giving all the materials assignments or did by me. Mostly design verification we did every line to line properly. For physical design also, our experts have designed every test, every module test, every weekend assignments, and the regular PPTs. And there will be lab session codes. You can access all lab session codes here. Like here, if you see UVM is there. Lab sessions are most important. How you can access the codes and all. Here it is available. And interview preparation, we are giving the best interview preparation notes for every student. If you prepare only these notes, 100% sure you are going to crack the job. Okay, so that's what the quality we are maintaining. Not only technical wise, we are concentrating on aptitude, logical reasoning, these questions also, because those also important. Every company asks the aptitude, logical reasoning questions, and there will be weekend test. You need to do the theory weekend test, and also question and answers, like choose the correct answers you need to do. And here are the assignment submissions. So you can check your how many assignments are submitted, how many are not submitted. You will be getting daily attendance. You need to log in into our portal, and you need to put daily attendance. And if there are any placements, or if you need to submit any assignments, we will give you the assignments here. And if you face any issues, you can raise the ticket, and you can upload the resume to our placement cell. So it will be directly connected to our placement cell, where you will get the regular job updates and all. You can check here. Okay. So that's what our LMS portal we are providing to the students. So if you have more, if you want to know more about ProviLogic demo sessions, you just go through the YouTube channel. Here, the ProviLogic demo sessions are available. If you want to learn more, I can suggest you a best demo session if you want to know more about the design and verification. So here is here confused about VLSI career path. This is the one of the best demo session if you want to attend for a design verification. Okay, and protocol session is their best protocol session. If you are a beginner like that, you can just check our page. Okay. Still, do you
Ma'am,
have
when
any
you are
doubts?
going to start next lesson?
What?
Ma'am,
Next batch start physical lesson.
ma'am,
When?
Yeah, next physical design batch will start from July 1st week.
Okay, ma'am.
Yeah, if you are interested, please contact to us.
Hello?
Our contact number is given here. Yeah, please.
Ma'am, is
ma'am,
that
I have
AHP
graduated in
protocol, AHP
2018, ma'am.
protocol
I
is
have
explained in
experience.
YouTube?
Whatever we put in a YouTube, that is just a few concept only, not entire protocol. It's a very complex protocol, VIP development. So we don't put entire protocol into the YouTube. We put only few concepts.
Okay.
Ma'am, can you please elaborate how you carry the project section, like based on EDA tools, ma'am, for PD part, like
Yeah. For design verification, we are providing the Questa Sim. In Questa Sim, you can design the RTL, you can design verifications in system verilog, UVM. You can write a more test cases, test plan, everything. It's a good tool actually. And for physical design, we are providing Cadence and Synopsys. whatever available, we provide anyone to Cadence or Synopsys. Both are very standard industrial tools. For Cadence, we are working at 14 nanometer technology and 7 nanometer technology, which is a very advanced technology. And in Synopsys, we are working on 14 nanometer technology.
Ma'am, have you carried any, especially only project-based things in past, like for PD, ma'am?
We have only project based also, but we don't give that sessions only 1 or 2 students. If there are 10 to 15 students, then we can give that project based sessions. Only projects. If any students are there, like minimum number of people, then we can start.
Yes, ma'am. Interested. I'm interested, ma'am.
Okay. Whoever interested, you can ping to us. You can share to me. You can contact to us. We will note down. Okay.
Okay, ma'am.
Ma'am, can I ask a doubt?
Yeah, please tell me.
Ma'am, in which role we can assume that we'll get high salary in VLSI? Like which role? RTL design verification.
Both the design and verification are good only. Okay, you will get the best salary in both the design and verification. But openings wise, nowadays design verification have more openings compared to PD. But in future, we are getting the manufacturing hubs mostly in India. Industry is focusing on physical design, like layout side and manufacturing side, right? In future, physical design have good openings. But as
What
of
is
now,
the
PD
cost of the course, ma'am?
What is the minimum PTC we can expect from physical design and verification?
Minimum salary you can expect 5 LPA, 4 to 5 LPA in starting. If you are from IITs and IITs, you can expect about 10 lakhs. Okay.
Ma'am?
Yeah.
Ma'am, I have 8 years gap. I completed, graduated in 2018 ECE.
Okay.
Is it practically possible to shift from my career to VLSI, ma'am?
Yes, yes.
Present I am
You
working in
can
non-IT
shift
field.
the domain. Yes, yes. You can shift the domain, but better
Okay,
take
that's
design verification. Design verification means you can shift easily.
Could you
okay,
explain?
ma'am. But
Could you
Ma'am,
I
what
have
explain?
is the
just
cost
PD,
of
ma'am.
the course?
Sorry.
Cost of the course, ma'am, that you are providing for physical design.
For physical design, it's about 80,000 we are providing because tools are very costly, right? We are providing in
Ma'am, online, offline.
both same price, online and offline, both are available.
Ma'am, what is the cost of design verification?
We have freshers course and also experienced course like professional course. We are just now 2018
Perfect.
guy has spoke, right? So for that people, we suggest the professional course because they have the gap, VLSI career gap, right? So that they will learn more advanced level compared to the freshers. Freshers
Ma'am,
course is freshers course is 50,000 rupees in online and 65,000 in offline.
Ma'am, will you provide an internship for the final year student who study the BE electronic
Yes,
TC?
we are providing the internship also.
Duration,
What
ma'am?
is the
2-month internship is available. 3 months internship also available.
Okay. What are the eligible for this internship?
Um, Eligibility in the sense, if you are a final year ECE student, if you know digital electronics, basic digital electronics, then it would be good.
Can
ma'am,
I
what is
apply?
the cost for the
Can I apply
What
for
internship?
about
internship?
CGPA?
Internships, we have different types of internship. If you have any doubts, please contact to this WhatsApp number I'm sharing here. Just check.
I'm a fresher. I'm
Is
art
that
and
free
design
internship?
engineer. I'm familiar with Verilog and System Verilog as well as digital design.
Okay.
can you arrange like this RTL to GDS like workshop for UVM?
Yeah, definitely. Before we already completed the workshop for advanced UVM, where you will learn how to develop the test cases,
Can I
test
get a
plans, everything. Yeah,
Can I
last
get the
month
recorded
we
session video, ma'am?
Ma'am,
actually
could you
it's a
share the
15 days
WhatsApp number?
workshop. 15 days workshop
Sure,
actually
ma'am.
it is.
I will
Yeah.
contact you through LinkedIn, ma'am.
Okay, sure. Okay. You can contact me through
And
LinkedIn also. I will
Hello, ma'am.
respond. This is my LinkedIn. You can
ma'am,
contact
my
me on
last
LinkedIn
question.
also. Yeah, please tell.
One last one. And for this workshop, have you provided a certificate?
Yes. For this workshop, we provide the certificate. Our team will
I
contact
will
you
fill
on
the
Monday.
Microsoft Teams or Google form. Will be
Yeah. Our team will contact
already
you
will
on
be shared
Monday.
that.
It takes some time
Okay.
because there are a lot of people. There are nearly 600 people are there for certification. It takes some time. Next week we will share to you. You need to write the feedback of this workshop and we will share you the certificate. Okay. We will send a
What
mail
would
to
be
you.
the
You
cost of the
Hello, ma'am.
internship, ma'am?
Cost of internship is 5,000 rupees for 3 months.
6 months
And what
internship is
about
available.
Hello,
CGPA
ma'am.
required
Any course are
for doing
provide
internship?
analog VLSI means
Yes,
like
analog also we are starting from July. Analog VLSI we are starting from July. Very soon we will arrange a demo session also. You can contact to the WhatsApp number. We will send the demo session for analog layout also.
Madam, internship is online.
ma'am, I am interested layout engineering that purpose.
Okay, sure. We are going to start analog layout also.
Ma'am,
Ma'am, is there
interested
any
in
stipend based
internship.
internship required?
Could you provide for me?
Stipend based internships are there, but as of now we are taking only our students who are getting trained. We are giving the stipend internship for them.
Ma'am, what is the minimum requirement of CGPA?
70% is minimum required, 75%. Sometimes CGPA doesn't matter. If you have very good knowledge, CGPA is also doesn't matter. They just check your knowledge. Mostly whatever the profiles we are sending from our institution, they don't check for CGPA. They will check only for how much knowledge they have, whether they are able to crack the interview or not.
Madam, internship is offline or online?
Sorry?
Internship is offline or online?
Online only.
Online. Okay.
Yes.
Is there any details for it?
Yeah, you can contact to the WhatsApp number. We will share the details. And also the curriculum brochures, if you want, here it is available.
Okay.
Here. Okay, that's it. Okay, guys, thanks for your patience. You are just waiting
Ma'am,
till the end of the session.
when
Yeah, please tell.
Madam, is there any
These
VLSI related internships currently available, ma'am?
Currently batch is not available, but we will start soon in July first week.
When it enroll, ma'am?
You can contact to this WhatsApp number. I have shared in the chat box, right? Just contact to this WhatsApp number.
Okay, ma'am. Either certificate is useful for submit our college.
Yes,
ma'am?
you can submit in the college.
Okay.
Yeah. And also you are going to do best projects in internship.
ma'am, could you please resend your WhatsApp number?
Okay. Just a second.
Thank you, ma'am.
Ma'am, can I leave the session because I have class right now?
Yeah, sure. You can leave. Guys, thanks for joining everyone. And thanks for your patience. Tomorrow we are mainly focusing on the practical session. Today just a theory session is completed, right? Tomorrow we are going to explain everything in a tool. Okay. So don't forget to join for tomorrow session. tomorrow session is also same link. Okay, at
Hello?
11 a.m.
Madam.
Morning at 11
That
a.m.
we can get recorded session out of today's.
Yes, we provide the recorded session also. Both sessions will
Madam.
provide tomorrow evening. By evening, we will send to you. Okay.
Okay,
I will
ma'am.
give you the update in
Okay, ma'am.
Instagram. You can follow the Instagram page.
Okay, madam. What is
Ma'am,
Instagram?
certificate.
Probilogic.
Ma'am, certificate.
Hello. Hello.
Ma'am, when we receive the certificate, ma'am?
Next week.
Okay, thank you, ma'am. Is there any procedure for filling the
We will
Google
send a
form?
mail to you. We will send a mail to you. Those who have
Okay.
registered for the certification, you just need to write a small feedback.
Okay.
We will send the certificate to you. Okay.
Okay, thank you, ma'am. Thank you for your time.
Okay, guys.
Hello.
Hope
Hello. Ma'am, if you don't mind, can you extend the class for tomorrow also? Because there is no sufficient time, right? Within 2 hours, we cannot complete whole topics in the PD, right?
Hello.
Hello.
Ma'am,
Can you
share
can you
WhatsApp number, ma'am.
yeah, I have shared in the chat box.
Hello. Ma'am,
Hello.
I think, ma'am, tomorrow session is from 11 a.m. to 1 p.m., right?
Yes.
Can you
Yes.
extend like 1 hour or 2 hours for
Yeah,
tomorrow
yeah.
session? Because
Yeah, actually today's session is also 2 hours only, but it's
Yeah.
already the end of hours we took the session. We can extend, that's not a problem. If students are interested and they are listening till end, we can extend. Because those
okay.
all are huge concepts we cannot complete in just 1 or 2 days.
Yeah, and also practical overview also today they did not given, I think so.
Yes, yes. Tomorrow is totally practical.
Yeah, okay, ma'am. Thank you.
Yeah.
Ma'am,
Okay,
can you
guys, if
share
you
the
have
LinkedIn
any
of
doubts,
Murli sir? Ma'am, can you send the LinkedIn of Murli sir?
okay, sure, I can share to you. Guys, any other doubts you have?
Ma'am, is there a similar kind of workshop on design verification?
Sure, we will plan design verification on micro architecture and computer architecture. We are planning actually all the workshops in series.
Okay, when it will be?
In coming weeks.
Okay.
Okay.
Ma'am, what is the fee structure for?
We are the meeting is going to end at 7:30. If you have any doubts, please contact to WhatsApp number. Okay.
Ma'am, can you please ping the WhatsApp number again?
It's 91822. It's already there. Just please check. I have sent again. Even you can contact me in LinkedIn also. Okay. Okay, guys. See
Okay,
you
ma'am.
in the
Okay, ma'am.
next session, tomorrow session. Okay. Thanks for joining. Thanks a lot.
Thank you, ma'am.
Appreciate for your time. Okay.
Ma'am.
Yeah. Okay. Good night.
Welcome.
Thank you, ma'am.
Okay.
Hello, ma'am.